I'll also live stream this. So for those people who might be like up and about, I'll stream it on. I'll also live stream this. So for those people who might be, I'll make sure I live stream it on YouTube. So I'll stream it on. Okay, we have 2 more minutes to go. So while we're waiting, can I ask a question? And the question based on how did you guys find the notes? Are they digestible? Like when you read them, are you able to understand? And if, if, if it's understandable, then if there was any issues, what could have been the issue like on a personal level? Like what would you like to do differently, or what would you like to be able to see happen? You can unmute.
This is Donald. Hi everyone. So far I'm okay because I'm doing the loops, and I'm just getting errors because maybe of the typing. When you're typing, maybe you're putting in something which is not supposed to be there. But so far I'm okay.
All right. So were you able to correct the errors?
Yeah, sure.
Okay, cool. Yeah. Thank you. Anybody else?
So far, my name is Nancy.
Hi, Nancy.
Hi. So far, and fine, thank you. I logged in 1 hour ahead because I thought it's the New York time, but I confirmed later and realized you people are the South time. At the South side is Central time is 1 hour after.
That's cool.
But I'm a first time beginner. Like I'm beginning from zero, learning, and I like the notes so far. Most of them are self-explanatory, and the part that I got a little bit of problems, just like the person before me, I didn't get the name, is the typing. I realized when you type something and you don't type it correctly, you always get errors. But so far I've been able to correct most of that. And I've given myself a target, like every day I must do something concerning Python, so that because I'm a first-time beginner, I must put effort in it, because if I don't, I will easily fall out.
That's right.
Yes.
Thank you.
Nancy, this is Donald, but not the commander-in-chief.
All right.
Okay, Donald. Pleasure.
Welcome.
Thank you.
Just remember, when you do the typing, try to make it all lowercase all the time, unless otherwise specified.
Okay.
Yeah, especially when you type some of the very specific, like internal or built-in Python functions, they have to be all lowercase. Okay. Anybody else before we get started? We are at 4:01. Any other feedback?
The notes are good. Ruth.
Okay.
Can you hear me?
I can barely hear you.
Ruth.
Hey, yeah, now a little better.
I'm Ruth.
Hey, Ruth, how are you?
I'm fine, thank you.
Okay.
The notes are good. I've been able to follow the notes and I do quite a bit of practice.
Okay.
I'm doing Python for the first time, but I've had previous interactions with other programming languages.
Okay.
Yes.
So that means you find it very easy then.
Yeah, you can say that.
All right. Yeah, I mean, especially if you come from another programming language, Python tend to be very easy to understand. And especially like if you did, say, basic or visual basic, it's
Ruby.
almost, yeah, it's almost very easy. Like you might think they are more or less from the same, they're made from the same material. Okay, so I'm gonna go ahead and get started. And if you don't mind, unless somebody has any comment put out there.
Okay, I'm John.
Hey, John.
I'm John Bosco. Yes, I'm John Bosco.
Hey.
Actually, I thank you so much for this particular forum. At least I've been able to get most of the information. Like for me, I've got an interest in software-defined network, that is network programmability.
Okay.
And actually, through the little bites, I've come to realize that Python is a great language. I just hope I'll be able to get my basket to be full at the end of the session.
Very
Thanks.
good. Thank you for joining. Thank you for joining, John. I think we spoke earlier.
Yes.
Yes, sir. That's very good. Anybody else?
Good evening.
Hey, how are you? Beldina? How are you doing?
Beldina here.
Yes.
I'm fine. This is my first time in any program. I've not done programming before.
Okay.
But I'm interested and I'm looking for answers. But what I would like to request is that some might have so many questions because you've not done programming before. So I ask for patience for those who have done programming so that we can all catch up, and by the end of this course, we might all be able to be at the same page. Thank you. And thank you for this class.
Oh, no problem, Beldina. We will try by all means to be very patient. And if for some reason you don't see that, just let me know, so we can make sure that you get all the help you can. I mean, this class is not very difficult, but it will need definitely a lot of your time to make sure that you get the concepts right. Yeah. Okay.
Okay.
Thank you.
Thank
Anybody else?
Hello.
Yes.
Yeah, my name is Tom.
Hey, Tom.
Hey, I'm based in Texas, in Sugarland. I picked interest in this Python. Actually, I was doing our initial picked interest in Tableau in a different application. Then along the way, I realized I had to do SQL. Then when I saw this Tableau, I realized, when I saw the Python, I realized it's a good programming language for data engineering. So I just thought I can't lose this opportunity. And since the idea was mooted on this site, and then I became a member of this particular group.
Yes.
I've been trying to read all sorts of information I could. I have done the first quiz.
Okay.
And tried a few other scripts. There are still problems, but I'm pushing and I'm sure I'll reach there. I'm also reading the book you gave us. I really appreciate the time and everything you've given us. Basically, my background is electrical engineering, but as an immigrant, you have to find your level in the best place possible.
Yes, sir.
It's 7 years in this country, so I decided if I'm to move forward, I need to change direction because I can no longer use my electrical engineering degrees from my country. I'm from Uganda, by the way. I can't use my bachelor's from Uganda. I had to go for 4 years. I said I can't do this. So I'm trying to look for a shortcut. And here I am. Python and Tableau, that's my direction. And I hope I'm going to make it. Otherwise, I wish to thank you so much and encourage everybody to pursue this. This is an opportunity you all can't miss. Thank you.
Okay, thank you very much, Tom. Okay, so I see that Caroline is getting some issues with the microphone, but if you have any problem hearing me, let me know so I can raise my voice. I try sometimes not to do that because it might be too loud. So I'm assuming that's all there is, but again, I'll give you an opportunity towards the end of the session to ask questions. If you have any question, please just write it down. And we will also go around again. In the middle of the of this particular lecture or slideshow, I'll also give you room to be able to ask questions. So feel free, please, to ask questions. If you're shy, there's a chat room. Just put your question in there and put your name. Or if you could put your name, that way, if we don't get you immediately, then I can always get back to you based on your name and in the chat. Okay. So again, my name is Migot Ndede. Okay. I am a software developer. I'm based out here in Dallas, Fort Worth. Okay. So by profession, I'm a software engineer. And the reason why I decided to do this class was basically to see if I could share some of the little I know with the rest of the world. So we have like 3 different WhatsApp groups, and all those WhatsApp groups are ranging from, we have some people from Uganda, some people in Nigeria, some people in Kenya, others in the US, some people in Europe, some people in Mozambique. So everybody is basically out here, and not everybody speaks the same language. We all share one language, and that language is going to be English and Python, if you know what I mean. So I'll try to be very slow so that I make sure that I accommodate everybody. And the way we are going to do it is we are going to go slide by slide. This like PowerPoint by PowerPoint. After the introduction, we will basically jump to the next topic. Now, those will be the topics we are going to cover. If you looked at the syllabus, which I shared earlier, like a few days ago, it's basically the basics of Python programming language, and then the variables, the basic operators, the core data types, the numeric data types, the precedence and associativity, and also the exceptional handling. Now this, remember, is our first Zoom session, and we will cover 2 more Zoom sessions, and we also did the first quiz. For those people who did not get to do it, that's fine. I'll go ahead and repost it. It's no big deal. Once you do the quiz will always give you a feedback where you missed and the explanations to the questions and answers. So this is not like purely like for grade or anything like that. This is for all us grown-ups, but what we are trying to do is to make sure that we cross all the T's and we dot all the I's so that we can learn from this. And this could be a very good opportunity for somebody out there who is willing to go to the next level. Okay. This is my second time offering this class online here for the introduction. I've done a few of these Python programming classes, some of them actually inspired me to be able to get a little bit on the basic side. Because I was approached by some 3 students, okay? And they asked me if I could basically try to see if I could get to the basics so that they could get started from that level. So among those students, we have some of them right now in advanced Python class, which we started a month ago, and it's going to run all the way to mid-January. So when I say advanced, does not necessarily mean it's very difficult, no. What it means, we cover the same stuff, but we go a little bit more detailed. And then we also do applications as in machine learning, artificial intelligence, deep learning, big data, and all those good stuff, okay? So based on what you can see being the topic on the screen, we are going to go ahead and cover about 51 slides, and it's not going to be very long. I try to summarize them, and I try to make sure that I simplify so that we are all understanding them and on the same page. So if you see a particular section which you don't understand, don't be afraid to ask. I will be more than glad to stop, and then we address that issue. If it's going to be taking too long, then I'll note it down, then I'll go back and explain it in the WhatsApp group, okay, or in the streaming Google Class, okay. So like I said in the notes, Python has been around since the early 90s and late 80s, okay. Somebody decided to create a language, and that language now is what we call Python. Python is not based on the snake itself, no. Python is actually based on a very popular TV series at that time, which was very popular in Europe, okay? And it was created by Guido van Rossum, and this is somebody from Denmark, okay? Okay, we use Python for web development, okay, which we are, in the advanced class, we are going to be able to do that. But for those people who will be able to go with this class until the end, and may be glad to be able to join my advanced class, we'll be able to touch on that. Now we do software development, which in this case could be for scientific applications and also for statistics. You can use Python for those people who are familiar with, for example, statistics, as in predictive analysis, or using regression analysis, okay? We can use the data given to be able to predict the future in terms of stocks, in terms of weather and rainfall. We can use it for predicting even the sales, like the sales analysis of a given product in a store or a range of products. We use Python also in mathematics, and we also use it in system scripting for us in administration scripting of other, let's say in an environment whereby we need to be able to automate other stuff. So we'll be able to, let's say, for example, we want to find out the details about a given computer in a network, or we want to create Python to be able to install certain software in the network while we are gone. That will be falling under the system scripting. And those are some of the details which, when you're lucky enough to join my advanced class, we'll be able to touch on this, okay? So why, for somebody will be asking, what can Python do? Now, Python programming, believe it or not, it's not been around for too long, but it's been around short enough to have an impact. And some of the advantages of the impact you'll be able to see as we go along. So Python can be used on a server to create web applications, like I say. Python can be used alongside software to create workflows, okay? You can also use Python to connect to database systems, create applications, and to create websites. It can also be used for read and modifying files. You can use it to handle big data, okay? By like, say for example, we want to find the data analytics for all the traffic flowing in a particular city, let's say in Johannesburg. If we have the data, then we can say, with this data, we have the data sets. Now, if it's a large group of data or data sets, then we can use that to do the analysis to find out what time is the traffic heavy and what are the reasons, and can we predict traffic in Johannesburg like in 10 years from today? So that's where we bring in the statistical analysis using regression methods to be able to do that. And also Python can be used for rapid prototyping because it's so easy to understand, it's so easy to work with. You can easily create a small application using its libraries, which Python has made it possible for like different libraries for machine learning, for artificial intelligence. So we just call the libraries and we do the data analysis. Okay. All right. So why do we want to learn Python, and why are we talking about Python? So, you know, Python works on different platforms. The good thing with Python, it's open source. It comes free. All you have to do is just download it. For those people who did the download process, and then once you download it, you are able to configure. Once you configure, which doesn't take long either. Once it's configured, it's ready to go. So we have the Windows. It can run on Windows, it can run on Macintosh, it can run on Linux, and that can also run on Raspberry Pi. Now, Raspberry Pi, for most of you who are not familiar with it, it's a small piece of computer, almost the size of like a cell phone, okay? But it's a computer with, you can connect hard drive, it has memory, it has a motherboard, and you can do prototyping with it, as in doing research and so many other things, even building robots, okay? So Python has a simple syntax like the English language syntax. As you can tell, you can just type the word and then you're able to get an output, so long as the syntax is correct, okay? Python has syntax that allows developers to write programs with fewer lines of code than other programming languages, okay? Python also runs on an interpreted system, meaning that the code can be executed as soon as it's written. You don't have to compile it. So it's being run line by line as you go along with it. This means that the prototyping can be very quick without taking a lot of time, and also cutting the cost on terms of programming it. Like, you don't need a lot of people to do the programming, okay? Python can be treated as a procedural as a procedural language, and it can also be used as an object-oriented programming language. So that's the advantage it comes with. So it can be functional, it can be object-oriented, and it can be procedural, okay? So that means if you are building something very simple, you don't have to go the object-oriented way. You can just, so far the programs you see those are procedural. We are not even using functions yet. So that's the beauty of Python. So Python can sometimes be used, like if it's a large project, then you might just decide to use object-oriented programming. So until that time, then Python also gives you a way of using very small short codes to just do procedures. And you can call, for example, print statement or input statement, and those are functions in Python. Okay. And of course, we're using Python 3.0 and above. Now, remember, if you are using Python 2.7, for example, 2.7 and below do not have some of the functions you find in 3.0 and above. for example, the print function or the input function. And those are some of the things you can always look back and see. But if you want, I can always explain better, like in the notes. Okay. Okay, now Python features, some of the features which come with Python, or some of the features which are built into Python. So like we said, it's very easy to read. It's cross-platform. That means it can be run on Windows. The same code can also run on Linux. The same code can also run on a Macintosh. Okay, so for example, right now I'm using Macintosh. I can design a program here and then I give it to Nancy. And then I tell Nancy, go ahead and try that out. And Nancy just copy paste and then run it. Nancy could be using HP laptop, which is IBM compatible. So it's gonna be like on Windows 10, for example, and it can work. Nancy can take the same program and pass it to Ruth. Ruth will also be able to run it. For example, if Ruth had a different platform, like in Linux, she can just copy paste and then it's going to run. So that's a good feature in Python. Now Python has very good memory management. Okay, even though it's line by line, it might not be very fast, but the memory management aspect of it is built in and it's been optimized. So it's very, very well taken care of in terms of the speed of the program. Okay, so Python is easy to learn. Okay, large standard libraries, like if you're doing, lately I've been doing a lot of some machine learning, which I'm preparing for the advanced class. And I basically just call the standard libraries. Some of the libraries are pretty much for, say, for statistics, or you could just be using import math or import OS, or it could be, say, import NumPy. Okay, and those are some of the things we'll be learning. And when we get to that aspect of it, then you'll be able to understand. Okay, like I said, Python is also free. Okay, it comes free of charge. So, and then sometimes maybe you could have read like Python come with all batteries included. So that's quote unquote. That means Python come with everything. Just all you have to do, just turn it back. Just turn it on. So you buy it, or you download it, you install it, you're ready to go. But you have to have the knowledge to be able to use Python. And that's where we come in with this particular lesson, to be able to know what I can do in what situation. Okay. And then remember, it's open source. So it's free, it's open source. So it means if you are good enough, say in C or C++, or in Python or in any other language, you can look at the code for Python and see. You can add your own libraries, or you can create a library and share with the community and say, hey, I created this library, which I think is going to be very cool. The library could be for something which has never been done before, because remember, not everything has already been discovered. Okay. And then Python, if you do Python programming, sometimes you encounter errors or mistakes or warnings. So when you do that, we gracefully have to handle that. And when we do that, we call it exceptional handling. So we'll also touch on that, okay, and see how that works. Okay, so the most recent major version of Python was 3.0. It was released in 2008. It's been in the market. It did not take traction very much because most of the code base was originally in 2.7, and it's been around for a long time. So some of the libraries had not been released for 3.0 until 2014, when 3.0 started taking traction, because some of the libraries were now becoming very compatible with 3.0. Okay. You can also write Python like just using text editor. You can use Notepad, or you can use Notepad++. If you want, you can use, of course, we call it IDE. So you call IDE Integrated Development Environment. Now, that really depends on what you like. Some people use it with VS Code. Okay, some people like using Pony. Sometimes I use PyCharm. Most of the time, I use Jupyter Notebook. Sometimes I use Colab, depends on what is available for me immediately, but really does not matter. You can use any IDE you like, whatever you prefer. That's going to be perfectly fine, okay? And Python will still be happy with that. But try always to see if you can get your Python to work in an environment whereby it can give you some kind of annotation, okay, in terms of highlight, syntax highlighting or code completion. And that really helps you when it comes to learning, okay? And one of those IDE will be PyCharm. Another IDE for that will also be VS Code. But if you get really familiar with Python, you can even do Python in Notepad++. Or you can even do it in NetBeans, or you can do it in Jupyter Lab or Eclipse. So again, whichever way you like it. But the moment you become very, very comfortable with it, I would recommend you try a lot of those IDEs, then you compare, and then you know how they all work. Okay. So the Python syntax compared to other programming languages. Okay, Python was designed to be very readable, okay, and has some similarities to the English language, okay, with influence from mathematics, okay. And remember, Python object-oriented, it has a lot of support for mathematics and science, okay. So Python was also uses new lines to complete a command as opposed to other programming languages. Now remember, if you programmed, for example, I don't know what language you programmed in, but every language comes with its own syntax. In Python, if you program in PHP, for example, at the end of PHP statement, it's going to be a semicolon. If you did the same in C and also in C++, now in Python, it's going to be different. Now, instead of using curly brackets, Python will demand that you use what we call indentation. You have to indent. If you don't indent, then Python will need that. So that means if you don't use a very informative or user-friendly IDE, then you might get some difficulty because you will not know why the error is coming, where it's coming. So I would recommend very, very much that you use something which is able to give you code completion and also syntax highlighting to be your environment of choice for development. Okay. Okay. Python relies on indentation for syntax highlighting. Okay. Can be 1, 2, or 4, but pretty much most people use 4. Can indent up to 4 lines. Okay. And sometimes some lines don't need to be indented, so you don't have to indent everything. Okay. So for example, you can put a line of code, print it, and then it tells you indentation required. So some IDEs might not tell you that. Okay. So we'll also touch on loops, okay, which Don had already started working on that. And then we'll also look at functions and also classes. So these are the basics. Right now we are at the basics. So this is a good opportunity for all of us to make sure that we get the basics taken care of before we go to the more detailed one. Okay. All right. So we say Python is a very simple programming language. Like I said, when I started programming so many moons ago, we used to call it BASIC. We used to call it GW Basic, very old. That was before Visual Basic came into the market. Now, Visual Basic is basically running on top of GW Basic, the old Basic, but the Visual Basic now has Windows, which is helping you design the code. Just like in Windows operating system, Windows operating system is also running on DOS, the disk operating system. Now the Windows operating system is the GUI part, but the the bare minimum in the background is actually basic command line. The DOS command line, which makes it sometimes very heavy in terms of the resources it's using. And that's going to be a conversation for another day. Okay. All right, so we go back, we say now, is it worth learning Python? Why are we even thinking of doing Python? Okay, the reason why I think it's going to be a good idea to do this, Python is very easy. Most companies are now actually embracing Python. And earlier on today, I sent a link, somebody put in a blog, and I thought, man, that would be something good if somebody could read it. It's going to give you a very clear perspective of where Python is going with it. Major companies, talk of Facebook, talk of Google, talk of Netflix. A lot of companies, the big companies are using Python. And now, for a long time, even Microsoft has been using Python. In fact, they're offering Python certification. And as of a few days ago, the creator of Python joined Microsoft. So we are yet to see what's going to be the deal. And that's a good indication that very good things are coming along. Okay. So research and reports reveal that Python is one of the most preferred language in the 21st century. The reason behind its popularity is the simplicity, the huge community support. Like right now, we have almost 600 students. Last time we had about 300. So if everybody is successful and continued Python within the last, I would say with the last 2-3 months, we have almost 900 people. Now, as in be familiar with Python. And who knows, some of these people will go to the next level, and that really makes a huge community of Pythonistas. Okay. And also we have Python is easy and has a lot of inbuilt functions, libraries, packages, and modules. Like I say, there's mathematics, there's statistics, there's science, there's math. All those libraries are built into Python. You just have to import or call them. Okay. And that really helps a lot in learning, in terms of the learning curve. Okay. Okay. So a lot of tech giants, like I say, are switching. So this is a good time for you and me to make sure that we are ahead of them, so that next time they say they need somebody in Nairobi who can do Python to the advanced stage, then you'll be there. Put your resume, make sure that you're in for it. Okay. And that's why we're trying to do this. So not only Nairobi, it could be in South Africa, Johannesburg, Maputo, it could be in Lagos, could be anywhere in the world. With COVID, things have really changed. You can even do everything from your bedroom. Okay. So that's where it's going to come in, and Python will be giving us a lot of opportunity. Okay, like Tommy said, you will see a lot of advantages fitting very well with electrical engineering, being from that aspect of engineering part of it. So Python will also accommodate you in that respect. Okay. So like we said, easy, portable, supports a wide range of applications. Okay. It's up at the top. Other than talking about JavaScript, Python is one of those very, very popular languages. JavaScript is up there. We have Java, we have C++, but of course, Python is still going to be up there. And the good thing with Python, it's very easy to learn. So just remember, Python alone might not be able to give you a job. You have to be able to be good at it, and you have to be able to also support it with other languages, like say the database, the SQL databases, or the front-end part of it, like HTML, CSS, like CSS as in cascading style sheets, and those good web technology. Okay, but it's good to get started with this one to be able to get to know where the direction, what direction we're going to take. Okay. All right, Python variables. We did a lot of this the first few days. So we have different types. Okay. We have, of course, like I said earlier, always try to type lowercase when you do your Python and when you do variable declarations. Okay. You can declare variables in X. That's not bad, but it might not be very informative. Like if you come back maybe 2 days, 3 days, maybe a week later, it might not tell you a lot about what you did. So you try to be very descriptive in your declaration. Okay. So we have the variable names and also the conventions. So you can declare a variable like that, X. You can also declare it as a variable, or the best way would be like to declare like my underscore variable. That's going to be more readable. Okay. Other than that, if you are, when we go towards the end of this class, we'll touch on classes. When you do classes, you'll see that classes will probably be the object-oriented part of Python. Okay. So don't get intimidated. It's actually very easy in Python. But the way we do it is that we start each word with a capital letter. That's one exception in Python. Other than that, if you are to, let's say, declare a constant, say, for example, pi, or you say, I would like to say, for example, the pi is going to be 3.14. The pi as in pi r squared. So in that case, you can declare your variable as a constant. And that constant, you probably want to make it capital. It's just conventional. It's not a requirement. But it really helps a lot in terms of how you organize your code and how you make it available for other people to follow. Okay. So like in class, do not separate words with underscore. This style is called camel case. For example, you can say, instead of say my underscore class, just say my class. So the M and the C will be in capital. Yeah. All right. So we go to the next one. Okay. So Python variable usage. Now, just in case I did not say this, the notes you see here, I'll share them with you. I'll make sure they are available for you in Google Classroom, okay, so that you can use them or go back to them. And also, whatever will be available will be on YouTube, the same recording. So for those people who are not able to be with us, we'll also get this available to them. Okay. For a function, okay, type, use. So let me go back so that we have a flow. Okay, remember the type. Okay, we have variable, we have a class. Okay, now we go to the next one. Now we have a function. For a function, use a lowercase word or words. Separate words by underscore to improve readability. So you'll always find that they talk a lot about readability. Readability in the sense that your program has to be self-documenting, easy to follow for you and for your teammates, and also for somebody who will be coming later to understand it. Okay. Variables to be lowercase, single letters, not very much needed, but try to make it at least to be like, to be like my underscore variable. Class, like we said, camel case. Method will be function in object-oriented programming. In procedural programming, method will be referred to as a function. Okay, so like if you have a program specifically designed to do something, let's say we have a program specifically designed to find the area of a circle. we can decide to declare that and then put it in. We put that in a function. We put it in a function if that function or if that program is a procedural program. But if it's an object-oriented programming language, object-oriented programming, then we'll talk about it being a method. But remember, method and function are the same thing. The syntax and the way we use them are the same, just the name will be method will be as to object-oriented, as function will be as to procedural programming. Okay. Now remember, I talked of constants. Use uppercase, for example, the pi equals to 3.14 or 22/7. Okay. The module, use a short lowercase word or words, separate words with underscore to improve readability. Okay. So if you design a program before and you are not aware of this, this will be a good way of going back to see if you can follow this convention. These are not requirements, but they are conventions. Good to use, like good practice. Okay. So somebody looking at your program will know, you really know what you're doing. Okay. For example, that usage, we say A, first of all, when you use this particular symbol, which is a hashtag, that in Python means everything following that is not going to be seen by the interpreter. The interpreter will basically skip that, but it's going to be a comment. So this kind of programming here is going to work, but it's not recommended. Okay. So we say A equals to Nelson Mandela. And then we say B, comma C equals to A dot split. So that means A now is a variable. It keeps the word Nelson Mandela in it. And then we say, we want to split that Nelson Mandela, but we split that into two. Okay. I'm gonna run examples so you can see. I'll share. Okay. For some reason I cannot share that, but let me see. Okay. Okay, can you see my screen now? Where I'm going to type. Can you guys see?
Now we can. Yes, we can.
You see now, right? Okay, so we say Nelson Mandela. Nelson Mandela. Okay, that's we save the name in in A. Okay? So if you were to print A, we print A right there. So it prints A as Nelson Mandela. But remember, if you don't do that, you put A in curly brackets, it will still print it, but it's not going to be the right information you want. Instead, you're printing the A. You're not printing the value of A. Okay. What if we want to be able not to print that? So we just go ahead and comment it out. And then we say now, we'd like to go ahead and say B, comma, C. Then we say A dot, then you split. Split function is basically to split the contents of A into 2. But when we do the splitting, we're gonna go ahead and take the first, before the separation, put in the first variable B, and the last split after the space, we put in the variable C. So Nelson Mandela will be split into A and B. So we come back here and then we say print. Say, say, you can print A, B, you can print C, comma B. And then this is something we'll be using a lot, but right now, don't worry about it. It's gonna be called separation or separate, as in printing. So when we come back here, we just run the program.
I'll work tomorrow. I'll see you next time.
Tom, can you mute? Mute, please. Okay. All right. So here, remember, if you are using not a very user-friendly IDE, then it's not going to tell you what error you get. So right now, I see the error and I've already corrected it. So if I do that, then I'll be able to get something else. So I need to be able to put another comma. Then I run it again. And then this time now I get the Nelson Mandela. So if I did the A or the B, I can do that. I can copy the same one here. And then I just go ahead and print it, print a space, and then I do another print statement. Now instead of B, instead of CB, I put BC. What I'm trying to do here is so you see how that works. So I'm gonna go ahead and say, I didn't do that for me, but do the separation. I need the separation. So between the word Mandela and Nelson, or Nelson and Mandela, there should be a bigger, wider space. So go ahead and do that. Can you guys see that?
Yes.
Okay, good. Want you to be able to see it. So I'm gonna make it wider. Okay. So this program is good, it's working, but naturally it's not what we want. We would like to be able to say, something like this. Okay, name, and then you say names. Lucy, can you mute? Okay. All right, so if we say, for example, C, we're gonna say we want the last name. If I do like that, last name, and then I do, this one is gonna be first name. So in this one, we call, this kind of programming, we call it self-documenting program. Somebody will know definitely what we were trying to do. Okay, so we say here, let's go ahead and do first name. And then we say, this is last name. Okay. This is going to give us an error because we need to change this one too. So we're going to change the variable. This one will be first name. And then this will be last name. Okay. So we run it, giving us the same thing we're looking for. The advantage we have here, I can if somebody designed this program, they gave it to me and I need to, let's say, comment, or let's say I need to be able to make some changes, I'll be able to understand what they're trying to do. I'll be able to say, okay, this is exactly what they're trying to do and I can do it. It's easier that way than if somebody did something with, let's say, without exactly telling us what we need to do. So we go back here. Can you guys see the new screen now?
Yes.
Yes.
Okay, good. So we've come back here now. You see what we just did. Now below would be the recommended method of variable declaration, which is also self-documenting. Okay. So it's very important that you take all those hours, but you do the right thing. The right thing means conventional, it's okay. If you're lazy like me, you just put an A, B, and then, but you come back maybe 3-4 years later, your program might not be very readable to you even yourself. So it's always very good to be very explicit in terms of declarations of your variables, classes, functions, and your methods. Okay. So in Python, we also have what we call the bitwise operators. These are used to perform bitwise calculations in integers. Now the integers are first converted into binary, either 1 or a 0, or 0 or a 1. And then operations are performed on them bit by bit. Okay, that's the name bitwise operators. Then the result is returned in a decimal format. Okay. For example, if you have number 1 plus number 2, those 1 plus 2 is 3. But if you were to do it in bitwise, we have to convert them into binary. So we get the binary equivalent of 1, and then we get the binary equivalent of 2. And then we add those binary equivalences. And that is what we refer to as the bitwise operation, the bit by bit. Now, operators are used to perform operations on values and variables. These are the special symbols, okay, that carry out arithmetic and logical computations or operations. Now, the value the operator operates on is known as the operand. Okay. The value the operator is operating on is known as the operand. Remember that word. Okay, we have the operator, and then we have the operand. Okay, now Python operators are the constructs which can manipulate the value of operands. Consider the expression of 5 plus 3, which is equals to 8. Now here 5 and 3 are called the operands. Like example I used previously, 3 and 1. I'm sorry, 2 and 1. Those are operands. Now the addition sign is going to be the operator. Okay, so we say 5 plus 3. We say operand, operator, operand. Then we get the solution. So we say 5 plus 3 equals to 8. Okay, Python language supports the following types of operators. We have arithmetic operators, which is like 1. Okay, number 1 we add, number 2 we divide, number 3 we multiply, number 4 we subtract. Those are arithmetic operators. Comparison. We can compare one with the other. We say, if this equals to that, then what? Those are comparisons. And then we have the assignment. Now that's going to be the equal sign. We can assign, let's say, names. We can assign Nelson Mandela to the variable name. And then we can split the two using the split operator. Okay, so we do the assignment and then we can always split that. Now we also have the logical operators. Okay, the greater than sign, the less than sign, those are the logical operators. We have the bitwise, okay? Bitwise is almost like something you've never talked about before, but I'm gonna, in a few minutes, I'll show you. And then we have the membership operators. And then we also have the identity operators, okay? So this might sound unique or strange, but just bear with me, you'll understand that here in a minute. Okay? Now remember, a membership operator in Python can be defined as being an operator that is used to validate membership of a value. Okay? This operator is used to test memberships in variables such as a string. The string could be your name or my name. Okay? It could be a name of a place. It could be a whole, like a whole book could be like a string. We can declare a whole book and then keep it in a particular string variable. And then we manipulate it. Like we use that in, let's say, machine learning. We can say, we are going to declare all the emails which come in into spam email or non-spam email. And then we use that variable to be able to look through that string or through those strings to determine what kind of issues we have or what do we need to look for. Okay, so we say this operator is used to test memberships in variables such as strings, integers, as well as tuples. Okay. Okay, remember, you guys probably read about the tuple, the list and the dictionary, right? Probably did. If you did not, let me know. Okay, now membership operators as a whole contain a number of different operators. Okay, so we are going to talk about that shortly. Okay, so we go here. Now look, bitwise operators in Python are functions and or methods. Remember, I talked about the functions and methods. Those are interchangeable. If you are talking like in the early 1990s, you'll be talking a lot about functions. Now, if you're talking about the same topic in the years 2000, you'll probably be talking about the methods, but you'll be talking about the same thing. Because now most of the things are object-oriented. Now we talk about the methods. In the initial stages, most of the stuff were in procedural programming. So we talked about functions, but they are all the same thing. Okay. If I declare a function to find the area of a circle, I'm declaring a function. I can also say I'm going to declare a method to find the area of the circle. It's going to be the same thing, the same syntax, just different names, but the same thing, the same contents, everything. Okay. So say, for example, in simple terms, it is a process of converting. Now, back to this, we say a process of converting integers and strings into bits that are zeros and ones. Now, remember, computers don't understand the English. Computers don't understand you. They don't understand me. They don't understand Swahili. They don't understand Portuguese or any other language. Computers understands only zeros and ones. And for that, we have computer interpreters as in Python, or compilers as in C or C++. But those interpreters and compilers make it possible for the computer to understand by converting, okay, those integers and strings into zeros and ones. Okay. Now, by using these operators, you are urging Python to either shift them from left to right or convert them into a sequence of zeros and ones. For example, we can have 0, 1, 0, 0, which means something, or 1, 1, 0, 0 means another thing, or 1, 0, 0, 0, which means another thing. If you look at 0, 1, 0, 0 might actually mean 1. You, me and you, we are humans, so we can also determine it to be 1, and 1100 could be 2, 1000 will be 3, 1001 is going to be 4. Computer can only understand the binary, but me and you can only understand 1, 2, 3, 4. Okay, so that's been broken down. So we go back here, we say, in order to understand this better, take a look at the example below. Now, for example, x equals to 6 and y equals to 8. Now, when converted, their values in binary form will be 0, 1, 1, 0, and 1, 0, 0. Okay? So a while back, I believe a week or so ago, I sent a video regarding bitwise operators. For those people who had a chance to have a look at that video, it explains, in order for you to understand the bitwise operators, it will be nice for you to, first of all, understand binary arithmetic. A case whereby 1 plus 1 equals to 0, you carry 1. Okay? Okay. All right, so we go to the next one. And if you don't understand, please let me know. I will be more than glad to make sure that we're on the same page. It might not be now, but send me a message. Okay. All right. So let's go on to the next one. Now, again, bitwise operators in Python. Okay. Mentioned below are some of the most significant bitwise operators in Python and their uses. Okay. So you see the one in red, that's the %. It's known as a bitwise AND. Okay, the AND, like the AND, 1, me and you. Okay, example will be, me could be X and you will be Y. Me and you is equal to 0, 0, 0. Okay. The next operator, the bitwise operator, will be, I call it the caret, known as the bitwise exclusive OR. And that will be like you, okay, me, caret you will be 1, 1, 1, 1, 0. Okay. Now this might not be very clear for you right now, but again, I'll refer you back to the video. But if you don't understand that part, please let me know. I'm even willing to get back to you one-on-one so I can explain it better. Okay. And then of course we have on my keyboard, the next one, that vertical bar will actually be on up at the top on the return key on my keyboard. It's known as the bitwise OR. So X bitwise OR Y, it's going to be, it's giving us almost more or less the same result as the bitwise exclusive OR. Okay. So this will be sounding great, but as you go along, you really need to understand how they work so that you understand the logic behind what computer does and how it does it. Okay. And I'll put some of this in our upcoming quiz so that we understand it better by doing it. And then we have the Quigley. I don't know if that's the right name, but the Quigley known as the bitwise complement. Okay, so if I say the Quigley X, it's going to be like 0, 0, 0, 0, and then 1, 0, 0, 1. Okay, that's going to be a shift on the character just before the number 1. Okay, and then we also have the shift left. Okay, if you have 2 less than signs, those are going to be the shift left. Example will be X less than 1. Here the bits will be moved 1 step to the left. Okay. The opposite will be greater than sign, 2 greater than signs, and that will be 2 shifts to the right. Okay. Might not be, don't get worried, but go look at the video. If you don't understand it, please inbox me. I'll be more than glad to be one-on-one with you, so I'll break it down. If I have to do it in Swahili, we'll try that too. But don't sweat it. This is easy. This is just a way for you to understand how the computer does what it does. Okay. Okay, so if you look at A is going to be number 10. Okay, but before we do anything in that basic operator, we have to convert that 10 into binary. And then we say B is going to be number 4. We also have to convert that number 4 into binary. Okay, so by converting to binary, basically you keep on dividing it by 2. That number in question by 2. Each time you divide by 2, the remainder you put on the side, and then you basically, in sequence, you take all the remainders, and that will be your binary equivalent of that number. So we say A and B is going to be 1, 0, 1, 0. Okay. If you were to do this in let's say in your calculation, this you'll be able to get 0 at the end. Okay, so bitwise AND operator returns number 1 if both the bits are 1. Otherwise, it's going to return a 0. Okay, the bitwise AND, the ampersand will always return 1, okay, if both operators are 1. Otherwise, it will return a 0. That means I can say, okay, I want to see U A and U B. That means both of you. If both of you come, then my objective is met. And that objective is going to be positive, and therefore it's going to be 1. If I say I want to see you and only one come, then my objective is not met. And that means it's going to be a 0. And that means it's negative. So, and that can only be like, I can say, can I see you or you? But not both of you. So if both of you come, then I get my result 1. But if I say you or you and at least one come, then I'll be happy with that. Okay, so that's the basic operator. Okay, so we come here, we say bitwise OR operator returns 1 if either OR is 1, is true. So remember, in computers or in computing, 1 is going to be true always. 0 is going to be false. Okay, so if I say I want 1 or 1, and 1 at least show up, then my objective is met. Therefore, that's true. Okay, so you find out that we can say, if we say A, Cynthia, can you mute? Okay, we say A equals to 10, B equals to 4. So remember, 10 is 1, 0, 1, 0, and B equals to 4, which is 0, 1, 0, 0 binary. Okay, so remember the OR operator will be like, I want Cynthia and Esther. If Cynthia and Esther show up, then I'll be very happy that objective is met. But if only Cynthia show up or only Esther shows up, then my objective is not met. Alternatively, I can say I want Esther or Cynthia. Then if Esther or Cynthia shows up, then my objective is met. That means it's true. Therefore, it's 1. Okay. So with the next one. Okay. Bitwise NOT. Now the NOT operator. The NOT operator, sometimes we call it a negation operator. So returns one's complement of the number, which means if we have 1, 1, all we have to do is just negate them, turn them to 0, 0. So this one returns one's complement of the number. Okay. So if we had, let's say, A equals to 10, equals to 10, 10, which is 1, 0, 1, 0, we negate that, it's going to be negative. It's going to be like 1, 1. Remember, computers don't understand the negatives. So that's how we do the complement. And the complement, we use the NOT operator. Okay. Again, if you have any issues, please. This will not be easy to understand if you've never done it before, so I completely understand. Don't be shy, let me know. Inbox me and I'll be more than glad to explain that, okay? All right, I'll stop for 1 minute and then see if anybody has any question before we move to the next slide. Okay, you want to assume no question?
I have a question.
Go ahead, Jackie.
Yeah, kindly just go through the exclusive OR and the bitwise OR. I think I didn't get it.
Explicit OR or the bitwise OR. Okay, so come back to. You tell me which one. This one?
The one, the upper, let me see. No, I think it's in the previous slide.
That one?
Before that. Yes.
Okay.
The second and the third one.
Okay, so you see here, all they're trying to tell us, they're using the and percent, okay? The and percent here. I mean, I'm sorry, the %, and the and, okay? So they're telling us that, okay, if we don't use this symbol here, we can use this symbol, the and operator, okay? If we don't use the caret, we can always use the or, okay? But they're saying that imagine that X is 1 and Y is 1, okay? So I say X is going to be Jackie, and then I say Y is going to be Lucy, okay? And then I say, can I see Jackie and Lucy? I'll expect to have 1 as the result if both of you turn out. If only 1 come out, then the objective is not met. That means it's going to be, instead of giving me a 1, it's going to give me a 0. Okay. So alternatively, I can say, I would like to see if I can see Lucy or Jackie. And if 1 come or the other, then the objective is met. But if both come, then that's not the objective.
Clear, thank you.
But again, I would recommend you look at that video, and if you have more questions, let me know. Okay, so we did that part. Any other question? Anybody else? This, don't feel bad. This is going to be a little different in terms of those people who've never done it before. Okay.
Yes, I have a question.
Go ahead, please.
The difference, is there a difference between the calculations of the 2 types of OR? The bitwise, yeah, the one with the horizontal and the one with the angle on top. Is the calculation the same or are they different?
Right here, the one on the screen right now?
Yes.
Okay. Ask the question one more time, please.
Not this one, then the other one, the or.
Okay.
The next slide.
Then the one before that. The next
Yes, yes, this one. There's this one, and there were two types. Or is it calculated this way? And the other one that you had mentioned. The
Okay.
Yeah.
Okay. So this is Esther, right?
Yes.
Okay. Okay. Is it possible for me to share? Okay, Esther, share with me your information so I'll be able to explain in detail. Because here the calculation has been done. Okay. So
yes.
For example, we break down the number 10 into its binary equivalent. So if we were to divide 10 by 2 all the way, we keep on dividing it. Let's say 10 divided by 2 is going to be 5, right? Equals remaining 0. 10 divided by 5, I'm sorry. 10 divided by 2 is going to be 5, remain with 0. And then 5 divided by 2 equals 2. It's going to be 2, remain with 1. And then do again, 2 goes into 2, 1 times remain with 1. And then we take all those and then we come with 1, 0, 1, 0. That's going to be the binary. We do the same with the number 4. Okay. I don't know if I can do that on the clipboard here. Let's see here. Okay. I never used this one.
Mhm.
Okay. I think what I'll do.
Hey, Migora, I have an idea of explaining it in an easier way. Silas here.
Go ahead. Go ahead.
So the biggest difference between the two OR, the exclusive one and just the normal OR, is the way you set an example. If you have two people and you want them both to show up, right? The exclusive OR, if both of them show up, you turn it to a 0. You don't want both of them to show up. You just want one of them to show up. Like in a party, for example, you say, use an example, me and you, right? Yeah. If I show up to the party, then I'm recognized. If you show up, it's recognized. But both of us show up for the exclusive, we don't recognize when both of us show up. Cool. But then for the normal OR, if we both show up, we are counted that we showed up to the party. So it's you. If you show up, you'll be counted. If I show up, I'll be counted. If both of us show up, we'll be counted. So that's the major difference between the exclusive one and the normal OR.
Okay. Did you get that, Esther?
Yeah, actually, that was my question. Okay. Thank you.
Cool. Thanks, Silas. All right. So I was gonna explain, but please feel free to still get us engaged so we can explain it further if you need to. Okay.
Okay. Thank
you. There we go. No problem. So we go to the next one. That's the exclusive OR. We did that already. So that returns a 1 if one of the bit is 1 and the other is 0, else returns false, just like Silas explained it. So it returns a 1 if one of the bit is 1 and the other 0. Okay. So again, you can only do this with binary conversion once you do the conversion into binary. Okay. So I'll probably put something together in binary, like very simplified, like step by step, and then I'll share in the classroom, and I will also share in the groups, so that you can see just the way we write them and all that, so that you can understand them. Okay. Okay. So basic operators now. Python program now the same thing, but this time it's going to be showing you exactly how you can do this in code. So we come back here. I'm gonna share the screen. All right, so we come here and then we say 10, A equals to 10, and then we say B equals to 4. Okay, and then now we say print. We're printing A. And then remember the ampersand B. Okay. And then we say A and B. So A ampersand B. Now let's see what it does. Okay, can you see that? Anybody? Everybody sleeping?
You can see it.
We are here. We can see. We can see.
All right. That's
I can
good.
see it.
Very good. Okay, now we go ahead and say, okay, what about if we do this? Instead of the and, we go ahead and do this one right here. Okay. That will be something different. Okay. So what if we do something else again? So remember, now we do that one. So we are assuming it's taking A and B and then doing the conversion into the equivalent. But in this case, we have 10 and 4. So we add, okay? We do the ampersand, we do that, and then we go ahead and do that here. Okay? Oh, sorry, this one right here.
Excuse me.
Yes, sir.
I see that the code is already adding up the variables. Was there any instruction for that?
That's where I'm getting with this one.
Oh, okay. Because I was expecting if you say A or B, it should give us 10 and 4.
Yeah, you already defined them up there. You defined A to be 10 and B to be 4.
Yeah, but I thought it was just going to print the values for us instead of adding it up.
You see, in Python, when you put like this, the ampersand, if you put the vertical, I don't know what to call it, but the vertical line in there, it does, those are the operators, okay? It's not looking at it as a plus sign or a negative sign or a division. So it's taking the variables which are already stored in A and B and doing a mathematical operation on them.
Oh, okay.
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 So
I was expecting that there will be an operator that makes the operation possible.
Okay, what do you mean by operator? Because this is the operator right here.
Which one?
The operator will be.
Oh.
You see this one?
I was looking for the arithmetic operator, not the logic operator.
No, don't look at that. Now, right now we are dealing with different operator, like we call it the bitwise operators.
Okay.
Okay. So forget about the plus, the minus,
okay,
the negative. I mean the division and all that. So right now we are dealing with these ones here. Okay. All right. So we go back here and then. Okay, if you wanted to print something else, you come back here and then you say, we can do that. Remember we did that before. So go back here. And then we just put that operator. Okay. So if we run that, then Python has a way of looking at it. You see that?
Yeah, that's strange. How did we come to that?
Because it's already converting it back to decimal. I think you're confusing the binary and decimal because it's already converting back to decimal. Like it's doing the binary on the back end.
So the binary, this is the bitwise operations. So it's almost like a function. It's already been stored in Python, so it knows exactly what it needs to do.
Oh, okay.
So when it looks at the symbols, Python will take the variable contents, which are the values in those variables, and basically do the mathematical operations, but in the bitwise format.
Oh, okay. I'm a bit confused with that.
So
I was just bringing my past knowledge.
Okay, let me ask you. You say you are a bit confused with this.
Yes. Why? Because you said the print function, the first statement is in quotes, which is I do not expect it to have any to perform any operation. I expect. I mean the statement quotes A and B equals. I thought that was just supposed to be a literal statement to print. I was expecting that the value that will come out of it will be A and B.
I would like for you not to think in terms of the mathematical part of it. Think in terms of the binary or the hexadecimal or like the number. The way you'd say if I want to do the hexadecimal of 10 here, right?
Okay.
You'll be able to say, now go ahead and print for me 10. But in this case, we have to go ahead and say, I would like you to put hexa, but to keep the hexa, the value of what you find in the hexa, and then go ahead and print the hexa. Okay, so when you print the hexa, it's going to print the hexadecimal of what you know as number 10. And then I'm not really sure, but let's try what about binary? Can we do the binary? Let's say if we have the binary of 10, and then we save it in the binary. And then you come back here and then you say, go ahead and print binary. Okay. Let's see what it does. See that? So you see 0B is actually 0 and then binary. So binary of 10 is actually 1010.
Yeah. Okay.
If you want to do the binary of say we want to do the binary of number 4. Okay.
It's going to be
number 4 and then
0 1 0 0.
So here we just change that and then we say let's do that 4. Then we run it. Then 0B100, right? See that? Okay.
Yeah.
Okay, so when we do the binary and the hexadecimal, those are actually functions. Okay. Now when we do this symbol here, or we do this symbol here, or we do this symbol here, those are already saved in Python. Python knows exactly, when you see that operator, it knows exactly what to do.
Oh, okay. I was thinking because that symbol has a quote.
Don't forget about you were thinking. Now this is a new thought.
Okay.
Don't think the way you were thinking before, because you'll get confused.
Okay.
You see what I mean? I would
Yes.
like you to have this new thought.
Okay.
Yes, because when we go deeper into Python, we'll be able to even add numbers. Like if you were to add a number, for example, you just add 10. We can add, let's say, 10 plus, let's say, 20. And we know exactly that's going to be 20. I mean, 30, for example. But in this case, we are not dealing with that. We are doing the bit operators.
Okay.
The bit operators are going to be, let's say, I'm going to go back to the screen. Okay, the bit operators, Johnson.
Yes, sir.
Yes, are going to be this one. Okay. You see the bitwise operators. See the one in red.
Mm-hmm.
And this one, that one.
Yeah.
Those are saved. Those are actually already declared and saved in Python. Just like if you were to do the modulus, or you were to do the plus, or the minus, or the division.
Okay.
Huh?
Okay.
But I'll share these notes with you, but please also read, and if you still have any questions, feel free to contact me.
Okay.
Okay.
Thank you so much.
Thank you. All right, so that's the end of what we call the bitwise operators. Okay. So for those people who might have gotten a chance to read about Python data types. Now remember, we've been talking about the numericals. Like so far, for a few minutes now, we've been doing a lot of stuff with the numerical, the numbers, the 0s to 9. Okay. Now the data types, we have 5 different data types in Python. Okay. We have the numeric, the dictionary, the Boolean, the set. And
Hello, Malimu. Hello.
Yeah, go ahead, John.
So you have just said for the bitwise operators, we'll be normally using the bitwise AND, bitwise OR, bitwise XOR. How about where will we apply the shift left and the shift right operators?
Okay, I'll show you. I'll show you. Those are whatever we are doing right now is a summary of what will come.
Okay,
So,
okay.
Even though I did not mention it, but they have their place. They have their place to play in Python. Let me show you if I could show you real quick. Okay, bitwise. Okay. There'll be typical examples of what they do, how you use them, and everything. So, okay, let me share this if I can. I'm gonna divert from that one so you can see this one real quick. Okay. For example, right here, look, you see on the screen?
Yes.
Okay, you see like binary shift left. You see that number? A,
yes,
2, and then this one 240. Okay, so the left operand's value is moved left by the number of bits specified by the right operand. Okay, so we shift to the left, we shift to the right. Now these are just examples. Now if you go deeper down there, it will show you exactly how it works with those. Okay, see, like if we were to save, let's say we were to save those in there. Okay, it will shift that 2 spaces to the left and 2 spaces to the right. So this I would recommend you probably want to check on. I'm going to put this in a chart. That's one area you can check, but again, I have them very much explained in the notes, which I'll also share. Okay, but these are the way the computer actually does its operations. So when you do the execution, you see what you see because of what the computer did. Sometimes you should not be surprised, like, how did that come around? How come this is like this? Why did it come like that? So it's basically to tell you exactly what to expect and how it's gonna come. Okay. So
okay.
Is that good, John?
Yes.
But there's a lot of notes I'll share also in this one.
Okay.
Yeah. All right.
Okay,
so
thanks.
Here, you're welcome, sir.
You can proceed.
Thank you. By the way, I like the questions. That way I know we are on the right track.
Okay.
So we have these data types, and this is not actually drawn on the stone. The data types can always change, but these are the ones we currently have. You might have heard of like Frozen and all those other ones, but these are the basic ones. So we have the numeric, we have the dictionary, we have the Boolean, we have the set, and then we have the sequence type. Now remember, in the numeric, we have the integer, we have the float, and then we have the complex. Now the integer, just like you and me, will be 0, 1, 2, 3, 4 to 9. And then the float will be those ones with the decimal point. And then the complex numbers with those ones which we can use like in mathematical and also engineering calculations. And I will also show you the examples there. And then the dictionary, I did some notes on that. Okay, it's just a set of, it's mutable. So it's a set of records put in a dictionary by using curly brackets. Okay, could be my name, could be my address, my phone number, all in there. Okay, it's almost like in a phone book for those people who are able to see the phone book. You see somebody's name, their phone number, their address. Okay, first name, last name. Okay, and then we have the Boolean. Now the Boolean will be either the true or the false. If it's true, it's 1. If it's false, it's going to be 0. And then we have the set. Now the set are the unordered pairs, almost like the dictionary, but these ones are unordered, and they are also in bracket, in a regular bracket, not in curly bracket. And then we have the sequence type, which are the strings, just like your name and my name. Those are strings. We have the list. The list, those will be in the square bracket. Okay, it's almost in other languages, this will be fitting very well with what we call arrays. So it could be like 1, 2, 3, 4, 5, 6, but in curly bracket, in square bracket, that will be a list. So when we declare a list, lists are mutable. Mutable means you can write, you can change, you can edit it. Immutable means it cannot be changed. Okay, like to place are immutable. Now to play, those are going to be almost like list, but they are in a different type of bracket, which you will see here shortly. Okay, so we go here. The following are the standard or built-in data types for Python, which we just talked about. Okay, and then we have the numeric type, the integer, the float, the complex. There are 3 distinct numeric types. Okay, and then we also have the complex. In addition, we have the Boolean, which are a subtype of integers. Okay, integers have unlimited precision. Okay, so we can have 1,000. That's going to be an integer. 1,000.12. That's going to be a float. Okay. Strings will be like your name or my name, the character of A to Z, or it could be some special characters in there too. The string type in Python is called str. Okay, this string type. So if we say str bracket, and then we pass an argument in there, then whatever we pass with, we can change it to a string. It could be a number can be changed to a string. So if we say number 10, and then we say str open bracket, put number 10 close bracket, and then print that, it's gonna give us an equivalent of what that string is gonna be. Let me show you here. Okay. String. I'm gonna share real quick so I can show you. All right, let's see here. Let me know if you cannot see my typing, but I believe you should be able to now. Then you print that string. You run that, it's gonna be giving us 10. So that's a string. So string 10, unique, huh? So if we have, let's say we have an integer, you can always change to integer, change to string, change to float. And those are variable types and how we can change them. Okay. So we go back here, go back. Okay. Okay, so we come back here. So like strings are sequences of characters, your name, my name, name of a place, name of a city, name of a country. Could be a phone number. Phone number should be a string. It's not actually a number, because we only do it a number if we want to use it for calculation. But if like it's 254 0702 110, that's going to be good to be declared as a string. So the string type str. Okay. So we say Boolean type. This is a Boolean context. It could be the falsehood or the truth, the truthiness of a particular aspect of it. So we say, if you're 10 years old or above equals to true, then you can watch this movie. If you're 10 years old, if you're 9 years old and below equals to true, then that movie cannot be watched by you. That will be a Boolean declaration, for example. Now, Python 3 provides a Boolean data type. Objects of Boolean type may have one of two values, so it's true or false. Okay. Sets are unordered. They are ordered sequence of strings. So set elements are unique. It could be, let's say we can declare a set, and the set could be somebody's record. So name could be a phone number, and then could be, let's say, an address. Now in a set, each time you call it, it's going to be an ordered pair. It's not going to be in any sequence. Okay. So duplicate elements are not allowed, for example, in sets. So if you are to do, let's say, a record of several people, you don't want those records to repeat themselves, then you probably want to use sets. Because sets would be good. That way it's gonna avoid the mistake of duplicating somebody's record. So a set itself may be modified, which means it's mutable. Okay, but the elements contained in the set must be of an immutable type. So we can say, okay, the set can be modified, but the elements, we can put a set of several other stuff, but those sets within that set could be set within a set where what we call nested sets. And those nested sets, we probably want them to be immutable. That way, you say, if you declare somebody's, let's say you put somebody's phone number, we don't want it to be to be changed, or you put somebody's account number, bank account number, you don't want that to be changed. So you probably want to declare a set for these records within a set. That way they cannot be accidentally changed by somebody or by a computer. Okay. So we go back here, we say, okay, now list, remember list data type. Now you can say this is an example of a list. Now list will be square brackets. Within the square brackets, we can have strings. Could be my name, could be my phone number, all in quotation, and then separated by commas, and then my bank account, the country where maybe I come from, and maybe other stuff like, let's say, for example, race. Now remember, list is mutable. List, you can always change it. Okay. Now, to place, the same as list, but when we declare to play, remember the big difference is here. Sorry, let me go back. The big difference will be the type of bracket we put the to play is. I mean, the to play in. So we use the regular parentheses. But to place, remember, other than that, to place are immutable. Okay, so you also can use to place to declare something which you don't want to be changed because it's immutable. Okay, then we go to the next one. Okay, now the list and to play in Python are the set of class of data structure. This list is dynamic, whereas to play has static characteristics. Now remember, we talked about to place and list. The list has a square bracket and it's mutable. To place has regular parentheses and they are immutable nature. Okay. Now, if you are to talk of a dictionary, dictionary will be mutable, and dictionary will be like a value pair. Value pair means, for example, if I have my name, it's going to be name, colon, and then the name. So name, colon, may God. And then address, colon, my address. And then phone number, colon, phone number, all in full. So all this will be separated by commas. So it's going to be a value pair separated by a comma, but each and every value will also be having a declaration whether it's a string or if it's a numerical value. Okay, but so remember, it's going to be a curly bracket for the dictionary, and it's going to be mutable, and it's a value pair. Value pair, like, let's say name is John. Okay, first name is John, colon, no, first name, colon, John, comma, last name, colon, Ubuya. Okay, but remember, each name being a character, being a string character, it has to be in quotation. They have to be in quotation enclosed. Okay. So we come here, we say to play data type. So we say the difference, the list and the to play, which is also the same thing we just talked about. So they are mutable for the list, immutable for to play. Implication of iteration is time consuming. They are slow. Lists are slow. Okay. To plays are comparatively faster because, I mean, it's like you cannot even edit them. I mean, you cannot edit them, therefore they're going to be very fast, but you can edit the list. The list are slower. Okay, so these are really good comparison here. Okay, because we have the list is better for performing operations such as insertion and deletion. To play data type is inappropriate for accessing element because you cannot edit it. List consumes more memory. Okay. To play consume less memory. Okay, therefore they're faster. Okay. Lists have several built-in methods. Several, therefore they're slower. To play does not have lots of built-in methods, therefore they're faster. The unexpected changes and errors are more likely to occur on the list because there are lots of changes which can happen in real time while the program is running. Into play, it is hard to take place. Okay, so we go to the next one here. If you don't understand, please stop me so I can explain. Or if you want, you can chat.
Hey, I have a question.
Please go ahead. That's Sue?
Yeah, so yeah.
Go ahead, please.
Yeah, I just wanted you to kind of explain you said the sets are mutable, but the elements are not. So can you explain like an example of that?
That's a good one. So
yeah.
So sets are, say your name is Sue, right?
Uh-huh.
Okay. And then you have your phone number, and then you have your bank account, and then you have, let's say, other details. Then we declare that in a set. Okay. Now remember, those are in order. They are not ordered in any way. Each time you refresh it, they're gonna be jumbled up. Okay. But their value. Let me go back here so that you can understand it. Okay, so for example, you can modify the set, but you probably don't want to modify the record, right? But the elements contained in the set must be of an immutable type, which means you can declare a set, but you put in the set to play. So you use a to play to put in a set, so it's going to be a nested set of to play. We know to play is not mutable. Okay, so that's exactly what they mean.
So does it mean like if you have like phone numbers in the set, you can delete one phone number if you want, but you cannot change the actual phone number. You can drop like,
okay, you see, phone number will be a phone number. It's going to be a string, right?
Like if you don't want it in the list anymore, like if you have different phone numbers, if you don't
remember,
want it.
If you're saying a list, that's going to be different. List is going to be mutable.
No, sorry, a set. Sorry, in the set. Sorry, yeah.
Now, set is mutable, but the element in a set, you probably want to make it immutable. So set is mutable, but remember, if we declare a to play in a set, we're going to use the regular parentheses, and that element we declare in a set, which is a to play, we want it to be immutable.
Okay.
Okay. I'll try to explain that further by giving several examples.
Sure. Yeah. Thanks.
Is that clear? Better? So, like we have lists, we have dictionaries, we have to play, we have sets. These are all different, but they can always like be, let's say we can declare it to play in a list. We can declare a list in a dictionary. So these are variable data types, but they interchangeably can accommodate each other, depending on what you want to do. Yeah?
Okay.
But I'll give you a lot of examples because I know this could be a gray area. That way you really understand.
Thank you.
Yeah, no problem. In Python, there's no way you're going to slide without touching a list to play, dictionary, sets. They're all in there. So here we come. So now look, list, set, and to play. List is mutable. Set is immutable. Set is immutable. To play is immutable. Okay. Sometimes I might have a slip of the tongue, but correct me if I'm wrong. I hope I said set is immutable and to play is immutable. List is mutable and dictionary is also mutable. So list is ordered collection of items. Set is an ordered collection of items. To play is ordered collection of items. Now, dictionary, remember, is key value pair. Okay, they are ordered, it's mutable, and their declaration is a curly bracket. Okay, so list items in the list can be replaced or changed. That means the mutability. Set items cannot be changed or replaced. Okay, to play, items in the to play cannot be changed or replaced. Okay. I hope I'm not confusing the two, because it's going to be not so good if I get confused. I confuse you guys. Okay, so we come here, we have the core data types. Now the dictionary. In Python, dictionary is an unordered collection of data values used to store data values like a map. You can actually take, for example, let's say a location. You know, location, let's say Dallas. You know, Dallas on a map is going to be a dot. So we're going to say the city center in Dallas has a coordinate of longitude and latitude. That will be a good way of storing that value in a dictionary. So we can say the city center, we say the building, let's say a particular building in Dallas, let's say the City Hall, and we give it the value of that City Hall in the dictionary, which, unlike other data types that hold only single map, or single value as an element. For example, you cannot keep that kind of thing where you need the value pair. You cannot keep that in a set, but it can easily be kept in a dictionary, because dictionary will hold the value, the key, and the value pair. So if the key, the name of the city hall, and the value of the city hall. So the value could be, let's say, the coordinate or the point in the map. Okay. Now, key value is provided in the dictionary to make it more optimized. So that means when you go back to the indexing, it's going to make it very easy to find. It's very easy to index. Now, keys in a dictionary doesn't allow polymorphism. Now, right now, don't worry about what polymorphism is, but when we keep this in the bag, when we go deeper into object-oriented, you'll understand what polymorphism is. But if you want, you can look it up in the dictionary, but it's not going to make any sense yet. But keys in the dictionary does not allow polymorphism. Polymorphism, poly means many, and morph means to change in several formats. That's the easy way of explaining it. Okay. For example, in a dictionary, you can say 1, largest Python class. 2, say in, and then 3, sub-Saharan. So we have number 1 is largest Python class. Number 2, in, and then number 3, and then we say sub-Saharan Africa. So we can read it, the largest Python class in sub-Saharan Africa. We can print that out, then we say dictionary with the use of integer keys. So we come here, and then that way we can just print the word DI, the short for dictionary. Okay. So that's one example of how we use that. You can basically use any pair of values in there. You can say number 1, Cairo, and then number 2, you say Egypt. Number 3, you say Johannesburg. Then number 3, the value is going to be, for example, it's going to be South Africa. Let's say this. Number 4, we give it a name, say, for example, it's going to be Mozambique. I'm sorry, like Maputo, and then Mozambique. So we cover, the key and the value, put the key and the value. Okay. Those are some of the examples. So you come here and then you say in Python numeric data types represent the data which has numeric value. Like from 0 to 9, can be integer, float number, or even complex numbers. These values are defined as integer, as int. This int here will be a function. Float will also be a function, and complex also a function. Okay. Now we have the integer, the long, the float, and the complex. And of course, we have the subset of the integer being a Boolean. It's going to be true or false. Okay. Now, for example, in C programming, we explicitly mention the data type of a variable. Python does not need that. If I was to declare count, I just type count equals to 10. But in C, I have to say the type. I have to declare the type, otherwise it will return an error. Now, if I say the integer count equals to 10, that's going to be C. But in Python, I just say count equals to 10. In Python, I don't even need the semicolon. It's going to take it the way it comes, and that's the easy part of Python for us. Now, if it's a float or a decimal number, then it's going to be like a percentage. In this float, PERC equals to 80.45. That's going to be point for float. Now, in Python programming, we don't specify the data type of the variable explicitly, as we do in Python, as we do in C. Okay, in Python, we don't, but in C, we have to. So this should be a typo here. I'll correct that. Okay. All right, so we go back to here. Now, in Python, numeric data types represent the data which is numeric in value. We have the float, the number, the complex, and these values are defined as integer, float, and complex. So that's probably a repeat, but it's good to repeat so that we get to understand it better. Okay. So we have the types here: integer, the float, the complex. And if you use, if you want to know a type of a variable, you declare, you can just use a type, open bracket, close bracket function to determine the type of variable, the type of variable you come up with. It could be a complex, it could be a float, it could be an integer. Okay. Now this example here, this one will be a complex number. Now Python has a built-in complex data type, which can be created literally by just putting, let's say we assign a variable x to 2 plus 3j. And then if you type the word type and then you pass the variable as an argument to the type, it's going to give you back the type of that variable, which in this case is going to be a complex. Now remember, complex number object has two attributes. There's the real, which returns the real component, and the imaginary, which returns the imaginary component, excluding the imaginary unit. Now, if we had the real here, real will be number 2, and the imaginary number will be number 3. And pretty much this one is predominantly used in science and also in engineering. So at this point, we will not touch a lot of it, but it's good to know. So you have it when you reach a level whereby you need, like you really have to, for example, in advanced Python class, then you'll be able to apply that and you'll be able to see it. So now it's just good to be able to talk about it, and then we understand it. Okay. It also has a conjugate method. So conjugate in the sense that we can come here and basically find the imaginary aspect of it. And then we find the real part of it. And then those will be two separate numbers, and they actually mean something. So the complex is going to be real, 2, and then imaginary, be 3j. Okay. All right, so let's go here. The same example. Okay, we do that, we print the C, and then the type is going to be complex. We print the C, 3 plus 6J. Then we assign the 3,6 to C, and then we print C1. Then we get that. Okay, that's also another aspect of complex numbers. Okay. So we use it, we create it from real numbers. So we create complex numbers from real numbers. Now Python complex numbers can be created either using the direct assignment statement, like what we do here. This is the assignment statement we have here. Anytime you use like a variable on the left, and then we use a value on the right, we assign to that variable, we basically assign it. And that's exactly what we mean by this one right here. So Python complex number can be created either using direct assignment statement or by using complex function. Okay. Complex numbers, which are mostly used where we use two real numbers. For instance, an electric circuit, which is defined by voltage V and current C, are used in geometry for scientific calculations and calculus. So this might not mean a lot to everybody, but let's say you're doing some calculations in electrical voltage or in some calculus math, then these complex numbers will come into play. Okay. Now, again, this just explaining how each complex number consists of one real part and one imaginary part. However, complex numbers don't support comparison operators. So if you have a complex number, you cannot use the greater than sign, the less than sign, less than or greater than. You cannot use those logic operators to do the comparison. If we do, then we get a type error. So we don't want that. Okay. Okay, that's still more on the complex numbers. It's a lot of it. Okay. Just same example, basically expounded on the previous one. Okay, so this one now we'll talk about the precedence and associativity. This is normally a very interesting point, because I mean, sometimes you can do your math and then you think you're right, but long behold, you're actually not correct. But in computers and science, and especially in like even finance, that can be a big deal, because you might be losing money, or you might be inaccurate, or you might cost the company or your organization a lot of money just by not logically following the sequence of events. Now, operator precedence, like for us, from East Africa, I believe we use BODMAS. It's bracket of division, multiplication, addition, and subtraction in that sequence. So if you're doing math and you have a range of numbers with brackets, plus or division and all that, there's a sequence to follow to get the correct answer. You come over here in the US, they call it I don't remember, but something, yes. It's the same concept.
PEMDAS.
Yeah, PEMDAS right there. So the same concept. Yes, thank you. The same concept. But remember, your math has to be correct. So that's the operator precedence. Now, the associativity only used when there are two or more operators with the same precedence. If you have a multiplication, a division, and a subtraction, then you have to be able to know which one comes first before the other. Sometimes, from my mathematical background, I might be forced to put the brackets so that I can separate the constants, and therefore it's going to be easy to get the results. Now, the point to note is associativity doesn't define the order in which operands of a single operator are evaluated. For example, consider the following program which is going to be here. Associativity of a plus operator is left to right, but it doesn't mean there's a F1 brackets always called before F2 bracket. Now I'm going to show you here in a short while. So the output of the following program is in fact compiler dependent. So let's see what I'm showing here. No, that's not right. I don't think I have it. Okay, let's see here. Anyway, I think I lost that slide, but I'll also note that down so I can show you. But basically, what it's showing us is we have to be able to follow a particular sequence to be able to get where we need to be for the math to be accurate. Okay, so we come here. We have the parentheses will always come first. Okay, the parentheses will come first, and the exponent will come second. Now, I think I did something like this in a quiz, whereby we have the right to left of multiplication that we do multiply twice, which means if you do that, then it's multiplying, like if 3 times 2 means 3 to the power of 2. The multiplication, division, and the modulus all on the same level. Okay, division and subtraction are all in the same category. So whichever one comes first doesn't matter. Which means if you multiply or divide or you do modulus, it has to be from left to right. Whatever comes first on the left will be the first one to be taken care of. The same applies to the plus and the minus. Whatever the minus, if the minus on the left or the plus on the left, that's the first one to come first. So that's the precedence and the associativity of the operators. Okay. Now, if you go down, you find that we have the bitwise, shift left and shift right. We have the relational less than and less than or equals to. So this will all come in sequence until the last one, which will be in terms of what you get. Sometimes really you don't have to master this, but when it comes to that level, then this should be presented somewhere for you to be able to do that calculation and get it right. Okay. All right. So we have the exceptional handling. Like I said, mistakes happen. In programming, it's always trial and error. If it comes to the level whereby you have an error, you probably want to handle the error gracefully. Okay, and that handling of the error gracefully, so that you don't have any problem in terms of like, hey, the operating system crashed, or it reveals some of the information you don't want it to be revealed. You want to handle the error gracefully so that it does not expose your program, or it does not mess up your environment, or even damage the system. So exceptional handling, even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. Okay, errors detected during execution are called exceptions. Okay, and are not unconditionally followed. So some are followed. That means if it's followed, then it stops and crashes the program. If it's not followed, then it will stop and it might not even give you an error message. So you'll be like fumbling to find out what is the problem. So it's always a good thing to be able to design your programs and you put the error handling in the program so that it can give you some way of feedback. The feedback has to be very friendly enough for you to know if it's, for example, it's error 400 or it's error 500. Like when you go to when you go to a website, it can give you error 500 means there's something wrong with the server, or error 400 could be something like that. So you give it description, and then it tells you what you need to do so you can pinpoint and be able to resolve the issue without any problem. So in programming, that's always a good thing. It's also possible to write programs that handle selected exceptions. For example, look at that one here. So we do the while statement. It's a while loop, okay? So we try and catch. So in this case, we try to catch the exception. Now we put the input statement, and then we say, please enter a number. If you were to do this, if you don't enter number, then you don't declare it to be handled correctly, then you get a nasty error. So in this case, it will print, oops, that was not a valid number, try again, which is a good way of handling that error. If you don't put that, then you just put a number, and then the person put, like, say, for example, something other than a number, then it might not give them a feedback good enough for them to understand what's happening. So this all boils down to usability. You have to make your programs usable. You have to make them user-friendly. You have to make it such that somebody do understand how to use your program without scratching their head. Now, this above example asks the user for an input until a valid integer is entered. That allows the user to interrupt the program. You can always, like in Linux and in Windows, you can always interrupt a program by using Control-C. In other operating systems, it might be different, or in other programs, or in other environments, it might be something different. You know? Note that a user-generated interruption is signaled by raising the keyboard interrupt. Now, that would be like Control-C to stop and terminate it. Could be Control-Z to just pause it and be able to examine it. So that's what we call the exception handling. Okay. Right, and then looks like we're done. So for now, and thank you guys very much for attentive listening and also for the questions. And I noted whatever we need to add on top of this to be able to communicate to you so that you can get time and read them. I open the floor for questions if you have any. Anybody, any question? Just unmute and talk if you can't, if you can. Benjamin, you try to talk? Can unmute.
No, I don't have any questions.
Okay. Anybody, any question? So I'm going to assume that nobody has any question.
I have a question.
Yeah, please go ahead, John.
Okay, when you are displaying the result for the various bitwise operators, like let's use an example of ampersand. So let's say we declare A is 4, B is 5.
Okay.
Then you say print bracket. Then you say A ampersand B is equal to the double quotes. Then you say A ampersand B equal. So I was asking myself, you can just help me understand the first statement.
Do you have whatever you explained? Do you have it typed on the screen?
No. Just randomly, arbitrary example.
So I'm not sure if I understood your question though. Can you see the screen?
Yes. Okay. So my question is here.
Mm-hmm.
What would this syntax implies. Print and double quote A ampersand B. Yeah, you. Yeah, yes.
Those ones are just actually to explain what's going to happen. I can say here, okay, I can say here, see what we get. See what we get. Okay, and then I put that in there, and then I go ahead and no, sorry, hold on, that's not right. Hold on, I think okay. Okay, so here, when we say this, okay, we run it. You see here, signal to it's actually sending a signal to Python, okay, to be able to make this a label, okay, so that you can say see what we see, okay, here, okay, see what we see here. You see that?
Okay.
So these are just labels. You can say for example, I want to say this one, right? Okay, let me come back here. I want to say this one, right? Say name and say okay. And then I come back here and then I say, now I want to be able to print, okay? But the name I'm going to be printing will be John Bosco. So I want to be able to print John Bosco, but I want to be able to have that as a name. But what if,
I'll just pay the difference.
What if I put that? Okay, so you can put that one.
Okay, let me see.
Giving us the name Bosco.
Problem is sometimes when we
see that,
do this.
You see that?
Yes.
All right, that's good. So that's just all it is. Anything in quote in the print is actually a label. But remember, we use the variable here to be able to echo out what the name is. Okay.
Okay.
Anything else?
Okay. So suppose let's say we omit this, give this name. We say and a double quotes. Then you say the percentage name.
Here. Percentage.
Here on the first statement.
On this one here. Okay. Where?
Yeah, this one. Yeah.
Where do I put the percentage?
We remove, give his name. Then you say, we just say percentage name of the variable.
Over here?
The next on the print statement.
Okay. You want to share your screen? Tell us what you have in mind. Are you in front of a computer?
Yeah, but is that, I was just asking here, like let's say
I'm willing, but I'm just not understanding where you want me to put the percent.
Here, there.
Here.
So we delete from the end, the initial quote to the end quote. Then we say, yes.
Okay.
Then we say name.
Okay.
Then yeah. Okay. Yeah. Then okay. then here, I was testing something, but I doubt if it will work.
You know what you can do, just test. It's all good. If it doesn't work, that's fine. And you can always share, and then we can fix it. Is
Okay.
that, hold on,
Yes.
hold on.
Yes.
Matt has something here. Let me see if I can copy. Hold on, okay? Okay, so you come in. This is what Matt shared, right? I'm not really sure if that's what you want. Matt share this one. Matt is giving us an error. It's not defined, so we have to define. Say we define age, okay? It's 50. Say 50, okay? And then you want to now go ahead and just print it. Is that what you're looking for?
Oh, yeah, that's what I wanted.
So Matt saved you a day, man. Thanks, Matt.
Thank you.
So that's exactly what you're looking for, right?
Yeah.
So here, remember also somebody shared that with us on, I'm not sure what group you are in, but somebody shared this in the group. Mario did. And this one is basically telling the thing to look for that variable, but fill it in. It's almost like a template, fill in, and then tell us what the whole thing is. Okay?
Yeah.
Okay. Any other question?
Okay. Just a minute. And then, like when handling the errors,
okay.
Can you define your own specific information to be prompted when an exception is?
Mm-hmm. Let me show you real quick, okay? Okay. Let me show you here real quick. I have all the time, so don't be any hurries. Okay. Okay, 2.
So, but
and then try.
It's on the
And then you say X, okay? And then you say input. And then okay, this is integer. And then input.
So it's something probable for 6 or 30.
Okay, you can say please enter. Enter a number. And then once you do that, then you come here and then you say break. Okay, and then you say exception. Exception, value, error. So once you put that value error, whatever the value error you want to print out. Okay. This one can be anything you want. Say higher. Okay. And then you can basically customize your error messages. Okay. And then you say, okay, try again. So here, when you run that, then we enter. Say we enter something, and then you do that. You see? So you can you customize that until, so it will go on and on until you get the right value. So you can save this one. Then that was so off, dude. Then you try again. And you try again. Keeps on going until you get the right number. So when you put a number, then it will be okay now. Now, if you stay, if it's correct, then you'll be able to just put this one right here. you can just print the value of x. Okay. So to answer your question, yes, it's possible and it's actually encouraged. So that way you customize your programs.
Okay.
Could you go through that again, please? Whatever you just went through from the while true.
Oh, the while. Have you guys touched the while on the loops? Okay. So here, in the while loop here, we are using the Boolean variable. Now we use the Boolean, remember, it's either true or false, right? So we say if it's true, then we are going to try that. So we say try. So this is try is to catch the exception. Try and catch it if you can. So we say, go ahead and declare the number here. Instead of x, we just say number. And then put, if that number is correct, then we want you to print it. If you don't put anything other than a number, then you say, hey, let's say, so that was not correct. And then you say, please try again. Okay. So when you come here, you see this, so when you come here, you basically run the program. Okay? So when you run the program, it starts here, it say, while it's true, go ahead and try. Now you try, so immediately it will come and do this line right here. If that line is correct, then it's gonna print the number. So here, you say, or if not, then it's gonna break and then give us an error. Now the exception error is here. Now remember, there are so many errors and we call them a keyboard interrupt. Okay, now let me show you here real quick. These are the exceptions you can use in your program. These are available out there. So for me, I use the keyboard interrupt. So when you go into like serious Python programming, this is some of the stuff you can use. So I use the type, I believe the type error. So you come here, you'll be able to see that. That's a value error. So I use the value error. So I use the value error. And value error. You can use any other error. So the value error here is going to give us keyboard interrupt, whereby it's telling me exactly the type of error we get. So let's go ahead and run the program. So instead of putting a number, I just put something else. Hey, that was not right. Please try again. You can use this in designing like a game. Say, design a game for your kids. And then you say, guess of a number. If the number is between 0 and 9, then print this. If it's not, then try again. You know, something like that.
Awesome.
Okay?
So, excuse me, kindly let me just ask. So, in this while loop, where exactly is the number that we are evaluating? Like, what sets the parameter for the input number?
Right here.
Yeah.
Integer. This is the variable.
Okay.
And then whatever variable we put here, it has to be an integer.
As long as it's an integer. Okay. Okay.
Yeah. So let's say it's not an integer. We say it's a float. Okay. How do we do float? Let's say it's a float. So we try again. If it's a float, it will accept something with a float. If it's a float, then it will expect something which it can actually work with. So in this case, remember the types of variables we were using. So let's go ahead and try this. Let's see if this can work. So we go ahead and try run it. It's an error.
You need to change.
Huh?
But the print line, change it to float.
Okay.
Yeah, on the bracket, yeah, on the print line. Yeah.
Who remembers this? Oh,
yeah.
Who remember that? Because whatever we declare here will basically be here.
Yeah, it has to match.
Uh-huh. So what do you mean?
So it's reading number, so that's why it's giving you the error, because it's not matching with what you have declared in the variable.
Uh-huh. So what?
So change on the print line on the parentheses, change it to float.
This one?
Yeah.
You sure? What if we did this?
The number.
Because we did this, it worked. Okay. I think my float. My float. Hold on. Let me see here. I think my float. Float should have been. I'm exhausted. I can't remember what I did.
Okay.
Float is, yeah, that's the float, right? Okay, so okay. So if it's a number, look, if it's a number, we just do that. If it's a float, why can't it work? Yeah, why can't it work? Let's see, let's try. It's giving error. Now, that's when you come to the error messages. And then you look. So we know this is not gonna work. But what if we try this one? String. Okay, let's try the string. So we remember it's a string right now, right? So if we put a number, is that a string?
Could be
Yeah?
a string.
So it's gonna be very tricky. Sometimes you have to try to see how it works. What if we just keep on trying? Let's say we try here. We say John. See? So string and numbers, they interact. Now, what if we just say 1? Is that a string? So you can treat a string as a number, number as a string. But if we do the float, it doesn't allow it. Okay. Do the float. For some reason it's doing it now. Maybe because I didn't do something. Did I put? No. Okay, now let's try now. Okay. Try that. So it returns. Yeah. Okay. So right now we try again. Let's say Francis. Like, yeah.
It's working.
So it's very interesting.
The system was freezing.
I think sometimes I'm using Colab. This Colab, this for lazy people like me. I don't have to. Yeah, I don't have to bring. I normally use this one right here. That's another one, but I know some of you use it too. But when you use it, it's sometimes very user friendly. You can come here, okay, and then you can use the same. So the good thing here, normally what I do, I just go back in and I just highlight, copy, bring it, and then paste it here. And then I can run it. No, that did not take the right thing. Let's see here. So if we run it, this one we run from there. Then we put a number. Let's say 6 point. I just put 6 and then we expect 6.4. If I put 6.3 or 6.4, then we enter, it gives us back that. So to your question, Sue, I mean we explain back, but to your question, John, you can use customized error message. For example, if you wanted, let's say, input, say first name. Okay, you can input first name, but you see, that might not help very much if you don't have a way of validating that. Somebody can put something else other than a name. Okay, so if they do something else other than a name, then your program might take that in and actually assume it's correct, but it's going to give you an error message where it can mess your backend system if it's, say, for example, database. So that's why we sometimes use validation. If it's a name, it has to be like between letter A and Z. And that's what towards the end of this programming, we'll do what we call regular expressions. It helps us a lot with validation procedures, how we can filter some of the mistakes. If somebody can put in, like, I don't expect you to put an ampersand or an @ sign in your name, but I expect to put an @ sign in your email address with a .com or .net or .org or whatever domain is. Okay, so that's validation. So if you did this, for example, this will take the name. You can say, go ahead and say, that's a name. And then you enter, brings to say. So if you say print, you can print the name, but we have to validate so that we can know if that's the correct value to put in and keep or save in the database. Okay, any other question?
Alim, you haven't talked about the race as an exception in exception handling.
Say again?
Race as an exception.
Race as in arrays or?
Not arrays. Race.
Race keyword.
Race keyword? What's that?
Race keyword. Raise keyword. R-A-I-S-E.
R-E?
R-A-I-S-E.
Raise?
Exception.
What do you mean? Break it down for me.
Okay, like a situation whereby as a developer you can choose to throw an exception if maybe a given condition is not fulfilled. Like it was just a small bit in one of the notes.
Mm-hmm.
Yeah.
For what we just did here, we raised an exception, right?
Yes.
This is an exception, remember? But we try to catch it here. We try, and then we give it a break, and then we create the exception here. This exception here can be anything other than value error. This is for the value, but what if it's not a value? It could be anything else. It could be zero division, for example. You can raise when the second argument of a division. For example, if you're doing a lot of like you want to make the program very customized, such that when an error is raised, then you exactly tell them what the error is for and how to fix it. And that's the customization. Is that what you mean, John?
Yeah, but you know, like from some of the resources you sent on variable names, types, and basic operators in Python, on the section of error handling, exception handling, they're talking about the try, the exception, and the final. Then at the last point there was a section for raise an exception, and they give some example there on how you can implement the same. So like I was just
Go ahead, please. Go ahead.
Yeah, so like I was just asking how you go about it, because from the example they give, they declared a variable. I say x is equal to -1.
Yeah.
And then they say if x is less than 0, and then they finally declared raise exception. Then you modify your own, what the message you want the person to receive when that condition is not fulfilled. Like the message there was, sorry, no number below 0.
Okay, let me give you an example. See?
Yes.
What I give, like I said, is about 20%.
Yes.
But it does not necessarily mean that I'm going to stop there. But if you want, I can expand on it, and I'll come more notes. But for example, let's say Kenya was giving people, what do you call those numbers? The numbers which were everybody needed to get.
The Uduma number.
The Uduma number, right? But you can only be given a Uduma number if you are 18 and above, right?
Yes.
So you're given a program. Let's say you are hired by KRA, and then they say, we want you to modify this program such that it can be user-friendly. Users. So you say, put in the age, and then normally we don't put in the age, but you put the date of birth. And then in the background, the program will calculate the date of birth from today. Say the date of birth was 1980. It will calculate date of birth from 1980, and then it will spit out and say, this guy's age is 40, right? So if the age is 40, then this guy qualifies. If they qualify, then that means you've already validated that. Now, the validation will say, if the age is 40, then go to the next. Otherwise, check, which means if the age is less than 18, then stop and print this. So print your age is not enough, or your age is under the person who is supposed to get. Your age is under 18, and therefore you cannot get to Uduma number.
And that's the exception, right?
Yeah, that's gonna be, you can put that in exception.
Okay.
And then you can say, okay, we only want this movie. Say, for example, you guys say you work for Netflix.
Yes.
Netflix say, okay, now we did a program here a long time ago. Now you're a very good Python programmer. They hire you on board, right? And then they say, we want you to change this so that this movie, all movies rated certain, let's say R13, can only be watched by a certain age group. So that will be a very good example whereby you use the exception. Now the exception will be whatever you want it to be. It could be, it might not even be the value. It could be the value error, or it could be anything else other than the value error. Now, all these are acceptable. Depends on where you use them. Now, if you did that, then you can say if the age is 13 and above, then the movie can be watched. So, which means in the interface of that movie, or the person who owns that that account has to put their date of birth. And then your program will have to calculate and then allow them to be able to use the program. Otherwise, the program will not accept it, and it will not let them continue to the next screen. Okay. So I can throw more. I'll definitely throw more examples. Okay, and also with programs in there, so you can see different scenarios on how to use the error handling and the exception handling.
Okay.
No problem, I'll do that.
Okay, thanks.
But if I forget, just remind me, but I know I'll definitely do that.
Okay.
Okay. Any other
Yes.
questions? Anybody else? You want to ask a question? Just put it in the chat. Looks like the microphone giving you a lot of problems. Anybody with any question?
Yeah, I was wondering, in real life, where do you use bitwise? Bitwise.
Okay.
Like in real life scenarios.
Let's look at. I really cannot think of that on top of my head, but I know it could be some very advanced programming, like in science and math and all that. So it's in real life. Let's just Google in real life. Where do we use bitwise operators? So, like in let's say in networking, in computer operations, like let's say IP address, the MAC addresses, the hardware register operations, data compression, like very low level stuff, and security and encryption. Those are some of the places where you could be using bitwise operators. So in if you don't mind me asking, what's your area of specialty? So, well, what's your area of interest?
Now, I'm actually in a Python data science class, so
Okay.
so
So,
just
okay, no
kind
problem.
of
So,
brushing my skills. Yeah.
okay. So you find that in regular day-to-day life, you might not be able to use it, but when it comes to network, let's say very heavy network, hardware register operations, data compression, encryption, security, those are areas whereby you might find a lot of usage for bitwise operators.
Oh,
Yes.
I was just kind of wondering. All right, thank you.
Welcome.
I have a question about exception handling.
Okay.
At the end where when you write the exception, like
Okay.
the way you said print and then you write the error, can you like do another function apart from printing the error? Like maybe send the person to do something else, or
Okay.
it's just
Okay. All right. So let me ask you, have you done in the selection whereby you have the if else statement?
I read a bit of it, not
Okay. So,
yeah.
yeah, okay, no problem. So, you know, those are some of the cases whereby, like, let's say for if else in Python, right? Let's say we have several other conditions, so we can go back here and say if statement 1, then print. Statement 2, print. So we say here, you can use a while statement, but if statement will probably be more usable. But in this case, let me go copy this and then we run it, then we can make a few changes. Okay. Okay, so we say the amount and then we enter the amount, okay? And then we say, let me make it bigger. And then we say, if amount is less than 1,000, then we go ahead and say, do whatever you get with that amount but we want to do the discount. Say it's a sale. So say if the amount you are able to spend, okay, let me scratch all that. Say you're running a store and you want to run a sale for Christmas or Thanksgiving. Now, say if somebody come into the store and make a purchase, let's say the purchase is more than 1,000, let's say 1,000 shillings, then we are going to go ahead and make a discount available to them. But if the discount is less than 1,000, I mean, if the purchase is less than, no, if the amount of the purchase is less than 1,000, then we just say the amount times 0.05, and then we get the discount given to them. So the more. So for example, if that's not what we did, instead of printing that, then we can go ahead and say, okay, let me see here. Let's run this program first. Let's say the amount is 900. Okay, we enter. The discount is 45. Now we basically printed that. Now you can take this example, and instead of looking for a discount, you can put your error messages in there to be handled. Say, for example, instead of we put the number, somebody, instead of putting the number, somebody just put like their name. Then we have to be able to say that was not the right thing to put, and then we split the error message, and then we give them a suggestion. And then we say, go ahead and try again. So we can use the while loop here with the if statement, all combined together to be able to give us the try and catch. Now let's go back here and search for if else statement with try and exception error. If else try. Let's see if we can get one which can work. Okay. Okay. Something close to that might be this one right here. Okay. So sometimes it gets really slow, so I open a new window. Everybody's using it. Do that. So you see that too? Now we want to be able to see age. Enter the age, exception, print. You have entered an invalid value. Say, for example, if the age, instead of entering the number, maybe they entered something like, maybe instead of number 8, they entered 8 as in characters. And then you say, if age, if they did the right thing, then we go ahead and validate that. Then we say if age is less than 21, then we print it. So let's go ahead and try that. Might not work.
Could you put that on the chat, please, so we can put it on our
Okay, this chat or the WhatsApp chat?
the Zoom chat.
Zoom chat.
I can copy it on. Yeah, please. Yeah, thanks.
You want this, right?
Yes, please.
No problem. I don't know if it's doing it. Didn't do it. Okay. Okay, so this one is slow. So let me go back to my live mind here. Okay, we enter this number. I'll try that. We run it. Let's say we put number 8. Run that. We didn't take it. So instead of number 8, say enter your age, you enter 8. You have entered invalid value. So this should be actually giving us invalid value here. Okay. Scooped up. It's not working now. No problem. Okay. You see this one now returns because we put number 8. We put 8 as in 8 letter, like we typed it out, but we should just put number. So it's telling us to run it again. So enter invalid character. So this one, if you did this, this should be able to take us back. And then when we go back, you should be able to run it again until we get it right before it can go to the next one. So we go back here, do it again, let's say 20. Okay, let's say 8 now. Then we expect if we put whatever is valid should be at least a number from 0 to 100 or more, then it should be able to go and do this execution. Otherwise, it will give us an error if it's not a number. So we expect it to go to this one. So we enter. So it's actually, you are not allowed to enter. You are too young. So it actually executed that and went to the next one. Okay. Else, if we entered, then it's gonna go, if we entered at least 22, it will go ahead and execute this one. Okay. So here we are using the if statement, the if else statement with exception, try and exception. Okay. So let's go ahead and try run it again. I'm gonna put 22. So 22 is gonna go to line number 9. Say it's gonna be welcome, you are old enough to, let's say you're old enough to enter. So we run it. 22, run it. Okay, 22. So welcome, you are old enough to enter. Okay. I don't know if that answered your question, Sue. Did that answer your question? Okay.
Yeah, you have. Thank you.
Yeah. One thing I can tell you, it's gonna be a slow process. Sometimes it's gonna be back and forth. Don't be worried. Don't think like you're not getting it. No. Sometimes the more you do it, the more it becomes second nature. But one thing I know for sure, the more you do it, the more it becomes second nature, the more it becomes familiar, the more it will kick in. So this is all good. All right. Esther, you have a question?
So Mwalimu,
Go ahead,
this
John.
is how we'll be, let's say, validating forms. Like when we, for example, when we'll be interacting with databases, like, for example, if a user enters his name, must validate that is indeed he cannot, let's say, for example, you have a form name, let's say first name, age, and let's say telephone number. So it means if age is an integer, so it means if you enter a string, the system will tell you that you have been inserted a wrong data type. So that's what we'll be using when we are implementing the exception.
Yes. And when you talk of form, you talk of, can you see my screen? You talk of something like this, right?
But it's faint.
Yeah, okay. It's not visible. Let me see. Let me look for another one. Okay. Can you see that coming up?
So yeah, better.
Okay, one more time. Okay, when we handle advanced Python, we'll be dealing with forms. Forms will be like, you can put almost something like what you see here. What you see when we run, let's see if this can run. It's gonna run in your style. Okay, let's see. Form is almost like here. You see this is a form, right? Now, when we take it a notch higher, there's a library in Python which we call tinter, tkinter. Tkinter will be able to help us with doing something like this. And then in the back end, we'll be able to design the validation. In the validation is what will resemble something like this. This is validation. So you can say this is an age, right? If somebody would put in a phone number, we can validate it in such a way that we can tell if it's a Kenyan number, or it's a Ugandan number, or it's a, let's say, South African number, based on, let's say, the values they enter. If 254, then we know it's Kenya. Could be 256, which is probably Uganda, and maybe 253, maybe Nigeria. So we can do those sort of validation. And then if it's an email, then if somebody put in an email, you definitely want to make sure that the @ exists in the email, somewhere in the middle there. After the @, then we have the domain. Of course, we have the domain is, for example, gmail.com. Okay, could be, let's say, .ke, maybe .ke, co.ke, or the way they do it in Kenya is different from here. So those are the validation. It could be a number, could be a digit. You just want one digit for, let's say, if it's an age, you don't want somebody to enter more than 100. Yeah. Or in there you can say, we only accept up to age 80. If it's below 80, then we give it a special treatment. Those are going to be under the validation. And the validation can be in the form here, like this one, or we can do something like that, the tkinter, or something like that. Okay.
Yeah. Yeah.
Yes. So, Bosco, looks like you cannot just wait. You really want to go the extra distance immediately. You guys are already 120 miles an hour.
Baby step is important. Baby step, one at a time.
Yeah, you guys are doing good.
Yeah.
I mean, keep me posted. Don't be afraid to share. I mean, let me know if there's something I can do to help. I'll be more than glad to. I'm going to add more notes on the error handling and also on the bitwise. I'll share those. I'll try to break them down step by step so we all understand, so that because the bitwise is going to be very important for you. As much as you might not use it, but it's going to be very good on the low level programming to understand that. Lucy, say what you want to say now.
You're able to hear me? You're able to...
Yeah.
Oh, thank you so much. Okay, I didn't even know that you guys are not hearing me, but I really wanted to appreciate you, Migot. It has been great. Every time I listen to you teaching, I get to learn so much. I get to learn something new. And I want to say that I love the way you teach. You break it down, and this you've always done. Let me just announce to the few who are still in this class that I'm a proud product of you. And I know that these people who have
Lost you again. Yeah, Lucy is one of my
are going to be proud, like you guys that.
Yeah. Lucy, like I say, I'm always very proud of you, the way you guys work so hard. Yeah, you guys.
So I also want to say that. Hello?
Go ahead.
Yeah,
yes.
I want to say that you don't read programming, you do programming.
Yes, that's correct. Don't just read it. Make sure you read and practice it. The more you make the error, the more you scratch your head, the more it sticks.
Please do it. Handle those errors. Yeah, you practice it. You practice it. And with that, you're going to get it. I am really happy to be part of this. And God, thank you so much. Thank you.
Thank you, Lucy. I'm very glad to be with you guys. Yeah, I really appreciate it. I just want to see progress. That's all. I want to see people like, I'll be so happy if you can come back and tell me, man, get a job in Python. Or
yeah, of course.
Together. Yeah. Yeah. Go ahead, Lucy.
And I really love this class because this is a class that is full of people who are ready to learn. They are asking a lot of questions and they are really reading ahead. I really was happy when you were asking, are people reading about loops? And my inbox is full of questions about loops, about functions. People really want to read these things and they're reading ahead. They're really reading ahead. I want to tell you that most people have really read ahead. Yeah.
That makes me very encouraged because I'm gonna start like what I did with your class. I was way ahead of you guys. So now that I know there are people who are working hard, I'll try to pump in some. I'll give you more books. Yeah, so that you can explore more, and then come back with more questions. Don't be afraid. Come back with more questions, so that we can do more. The more you do, the better. If you encounter difficulty, don't give up. If you have to take a walk, come back and try again.
Yeah, and they don't need to fear errors. Programming errors is part of you forever. So you get them, you handle them, and you learn, and you move on.
Hey, Migot, this Donald, how is the job market with the basic Python?
That's a very good question, Donald. Hey, when you say basic, what do you mean?
Like what we are learning before we advance to the next stage. How is the job market?
Okay. Now, depends on what your level is. I mean, you could be basic, but when you go to, let's say, you go to the interview, then you ace it.
Okay.
So it depends on the kind of interview you're looking for and what you have as in your background. Are you already in IT?
Yeah, I'm in IT.
Okay. So what do you do if you don't mind me asking? already?
I just left BOA last year.
Okay.
Currently, I'm with the AAA as a data analyst in the underwriting department.
You see, so you're already in there.
Yeah.
So there are very good chance that you can handle this, like you guys already reading ahead and say, for example, AAA wants somebody to do more of what you do, and then you put that in your resume, you put it out there.
Okay.
And I can tell you sometimes, I don't believe in luck, but sometimes luck can play very well for you.
Okay.
So the job market is there, so long as you don't put like elementary Python, because
okay.
We might be calling elementary, but this page, by the time we are done, it's going to be like a whole full semester of work.
So I can say like 2 years experience.
Yes.
Okay.
Yeah, 2 years of experience would be a good thing. By the time we're done, you shall have already even touched object-oriented programming.
Okay.
Like right now, what the advanced class is doing is almost the same thing, but we're just going into detail.
Okay.
And when I say detail, I mean, as of tomorrow, we are having a Zoom class with them, and we're talking of regression analysis. And we are talking of data mining, we are talking of big data, we are talking of how to use different libraries, as in statistics, to do the analysis and also visualize the data. So I can say with confidence that if you follow through with this class, by the time you're done, you will not be like elementary.
Thank you.
The notes are looking very shallow, but I also encourage you to read more. I'll share a lot of other material and links with you. So I intentionally make the notes to be very simplified so that we can be able to understand and not to intimidate. Like in the advanced class, I gave them something to do with regression. Regression analysis, for those people who've done some math, it has a lot of, a lot of Greek symbols, like summation and all those, and they're very, once you know them, they're very simple. It's just a matter of adding, matter of subtracting, matter of dividing, but the Greek symbols are very intimidating. But once you get to know them, then you kind of like say, wow, this is not exactly what I thought it was. By the way, let me share real quick what I gave them so that you can understand. This one you'll never, because this is how you can always predict the stocks, predict like the rain, the weather, based on statistical data which out there already. So we can easily, if we have a lot of clean data, we feed them into the system. And then once we feed them into the system, we use some calculation formula to help us to get to where we want to. Okay, I got it right. Here. But one thing I can tell you, I really enjoy working with Python. I've worked with several languages, but of all the languages, I really enjoy Python. It's just different. Wow, what did I do?
But Mwalimu.
Yes, sir.
I can see from the look of things, most of the system that runs in the Kenyan market, most of them are PHP based. A few systems run on Python.
Yeah. So let me tell you one thing. Yeah.
Yes.
I've worked with PHP for more than 10 years, and I still do a lot of my work in PHP. But there are certain which PHP cannot handle, especially in data science. So you find that you find a company in Kenya which might be into the fintech, but the fintech, the backend will probably be using a lot of Python. The front end will probably be PHP, not front end, but the website will be PHP. Okay? And borrowing a lot of the heavy lifting from what is already been put out there by Python. So there's a mixture of both worlds in most cases.
Oh.
Yes, sir. So let me see if I can. I really wanted to share that with you. Let me see. Yeah. So if John, are you already doing something to do with PHP?
Actually, I did that, my undergraduate project, I did using PHP.
Okay.
But I didn't like it so much.
Did you or did you not?
I didn't like it so much.
Yeah, so PHP has borrowed a lot of stuff from Perl and C++. So when you do a lot of stuff in Python, PHP will probably be something you want to do, but most of the time it's not going to be like a big deal for you because Python will take a lot of stuff in terms of what you can do.
Like I really want to have the best in Python, so that I'm thinking of, like, where I come from is an island, Mfangano Island in Lake Victoria.
Okay.
And most of our economic activity is fishing. So you find that most of the beaches, they still use the paper thing. So I want to come up with a big system that can manage all the fishing industry along the lake shores.
Okay, so that's a good idea. Though. You can put it in writing, like from a layman's perspective.
Yes.
Like what you need to be input into the system.
Yeah.
But if you look at my screen right now, you see the leftmost is the year, like year 2000 to year 2013, right?
Yeah.
Then following are the sales. So sales could be in the thousands. And also this could be like amount of rain. It might not be like sales in dollars or sales, it could be sales in shillings, or it could be just amount of rain in inches. But anyhow, what we are doing here, we take both, okay? Remember the X and the Y axis, okay? Now the X axis, that will be the independent variable, okay? The Y axis will be the dependent variable. That's what we are looking for, okay? So the combination of both, we are able to bring what you see on the screen, okay? What you see on the screen here is what we call a scatter graph, okay? And then in the scatter graph, we are able to come up with what we call, like, remember for those people who did math, like y equals to mx plus
c.
Is it
plus
a,
c?
the gradient, right?
Y is equal to mx plus c, where m is the gradient.
Exactly. So that's the same formula here. This is simple regression. So if we did some calculation, we are able to get the regression, which will be, this will be the minus 2.29, okay? That will be the M, okay? And then the 4624 will be the C. So we can easily, based on that, we can easily plug in what is X, okay? If it's 204 here, we put 204 in here, and then we do multiplication, and then it will give us a value which is 32, okay? So if we want to predict, say everything remained constant, if it's rainfall, the weather pattern is the same and everything, we can predict the rainfall the same in 2022 by just plugging in the numbers. Or we can predict the sale of following the same pattern, imagining this same guy using the same quantity, the store is the same place, everything constant, all the variables are the same, right? You can actually predict what his sale will be at the end of 2020 or 2021, based on the formula, which is regression analysis. So to your point, Dan, this is probably what, if you continue other than sticking to the basics of Python, you go into the detail of Python, these are the numbers which, when you come up with a graph like this, you'll be making a lot of people very happy where you work at. Like, I did some work here. I'm just sharing, of course.
Yes.
Yeah, so I did quite a few things. This is a prediction of whether somebody's going to have diabetes or not, or whether somebody is going to get heart disease or not, based on the data. You can predict. So you given like values, you plug them in. This will not make a lot of sense, but I'm just this somebody's heart condition. I'm just sharing it. And based on this one, you can decide to find out based on the sex, gender, the cholesterol, based on so many other input given, you can be able to determine if somebody's going to be getting sick from heart condition or not. Or alternatively, I also did another one here, which is, I believe that's number 12. This one for diabetes. We get a lot of, remember, the cleaner the data, the better for you. That data has to be clean. Okay, I'm gonna say something, but guys, don't think that I'm talking bad about Kenya. In Kenya, we might not have very clean data. So our prediction might not be correct. Some of the data might be distorted. Maybe somebody just did a guesswork. Say, for example, rainfall. If we have a good rainfall data for the last 100 years, and then we want to be able to predict the rainfall data for next year, if we had clean data for the 100 years, past 100 years, the data for prediction for next year is going to be accurate. The same applies in the financial industry, like stocks. The same can also apply in diseases. We can do training, we can do testing. Some of these, for example, Lucy, I'll touch base. In your class, I'll do a lot of this with you guys. So you get to know exactly how you can even predict. Like if somebody gave you all the good data. Now in Kenya, there's a place where we can go and get data, but I'm not sure how clean they are. If we want, we can go get the IEBC data sets, but it might not be all that correct, but they favor certain conditions. So we can grab that data and then we do analysis on the data. Now, this will not be able to predict, but we can be able to predict maybe how people will vote, okay, based on the data we have. If that data is clean, we can predict the pattern of people voting. Let's say in Mombasa County, let's say Kiambu County, Nyeri, Meru, maybe Busia, Kisumu. But if the data is not clean, we cannot guarantee. And that's the problem we have in most of the places, like especially in the third world, especially in African countries, whereby somebody can manipulate data and cut shortcuts. But if you come from a strict environment, like let's say, for example, the rainfall here, they can almost predict it. Sometimes they miss it. Sometimes they tell it's going to rain tomorrow, but it doesn't rain. because of the weather conditions worldwide due to global warming and change of patterns have really made it very hard. But again, that's not our problem. Our problem is to be able to calculate it and then wait for it to happen. Okay. So these are some of the work I did for the last like 1 week. But I'll be able to, for those people who will be joining me in the advanced class, this will be very key so that you can help you work it out. Okay. I hope that explains to you if Dan is still around.
I'm still here.
Okay. So that would be something, Dan, I would very encourage you, don't look at it. By the time you're done with this one, don't look at it like it's basic, man. It's going to be really detailed.
Okay, thank you.
So, any other question? Anybody?
No, I just wanted to make a comment.
Please, go ahead, Sue.
We can say COVID has reset a lot of predictions. Could we say that? Like, there's there's a lot of changes in a whole lot of things. Could you say maybe we are starting like a clean slate somehow for a whole lot of data?
Well, give typical example. For example, COVID has not changed the weather.
Not the weather. Maybe something like vacations, flying, like.
Yeah, it could be like the airline industry.
Airline. Yeah, there's
a lot of changes. The financial, for example, you have, let's say you bought some stocks, okay? Other than COVID, and I'm not against anybody, but the guy going out used to really manipulate such that he can just say something and that really make the stock market go crazy.
Yeah.
Yeah. So those are some of the external factors. And remember, in regression analysis, we also have whereby we give allowance for those kind of errors. Okay. So we can be either 0 or a 1, but between 0 and 1, we can have a range. And then we have accommodation for stuff like that. We say like, okay, if it's really worse, it's gonna be this one. If it's really good, then this one, but we have to allow some room for wiggle. Yeah, so to your point, yeah, I mean, COVID has really made a few changes. Yes. I see, go ahead.
No, I just said thanks for your teaching. It's really nice. Okay. I've gone through this class before, and
oh, you did?
Yes, I have.
The previous one?
No, no, a different teacher. So
okay.
I like the way you explain things.
Oh, thank you.
Makes it really easy.
I try to make it sound very African, so we're all in the same page. For example.
Yeah.
Yeah.
Hello.
Yes. Go ahead, John. John. Okay. I see Esther said this is a first programming class. Esther, you can do it. This class will be. This is going to be easy. So I'm glad you can be part of this class. So you guys, I mean, this first class, this Zoom session give me a lot of motivation to basically put stuff out there because, other than being the WhatsApp, it's going to be, I'm going to share a lot of notes. And also some of the books, I have quite a number of books in PDF format. Python has been around for some time. Different authors, some authors approach it from a different angle. So the more you read, the better you get in terms of different points of view from different authors. Okay. Anybody else? Irene, we didn't hear you today. Do you have a question for us? You can unmute, Irene. Okay. I'm going to assume that nobody else has any question for me. If you do, please go ahead and ask it. Irene, you have a question?
Yes. Hi.
How are you?
Good. I just want to say thank you too.
Welcome. Thank you.
For all that you're doing. I've been wanting to do this programming. It's my first time. I've never done programming.
All right, that's good.
And it's tough sometimes. I feel like giving up, but I'm trying.
Yeah.
Yes, thank you so much.
Thank you. And I hope this will be not a steep climb for you. Because I mean, Python should be very easy. Like when I started programming, I started with a language we call BASIC. And BASIC, just almost similar syntax to Python, but it's very easy. Python has made it much more easier to programming. And it's gonna get even easier the more you go in and the more you read. And the more you read, the better you become. Yeah.
Oh, okay.
So,
And
yeah.
I have a question.
Please go ahead.
How can I be able to change now from, what is it called? The binary to integers. How can you go back?
Okay, from binary. Okay, see, integer is like 0 to 9, right?
Yes.
To change from integer to binary, use bin. Let me show you. Okay, I'm gonna open a new window. Can you see my screen?
Yes.
Okay. Okay, for example, we have, let's say, number. That's a variable, right?
Yes.
Then that number, let's say it's number 1. And then we want to get the binary of number 1. Okay? So
Yes.
just the number. And that bin means binary. And then we just go ahead and print it. Now, you probably want to say, before you print that, give that also. Don't put the word binary there. It might be special as, might be a keyword. Just put binary. And then here we just come and say binary. Okay? And
okay.
Then when you print that, that's how you do it. Waiting for it to come up. Okay. Binary, that's going to be the one. If let's say you change that to, let's say 10, or let's say number 9, and then you change that. Okay, that gives us an error. So it's expecting a string. What's that? Sometimes this thing gets tired. So
yeah.
Yeah, so you might be thinking that I made a mistake, but if we just use number 1, if you took number 1. Okay, for some reason now it's not taking it.
Yeah.
Anyway, but that's exactly what you need to do this using binary. If you were to use the hexadecimal,
okay,
then you go to the hexadecimal. And then you print the hexadecimal. Those are going to be some of the things which you'll be doing a lot of. For example, that's it. I hope I did the binary right. I don't know why it's giving me error. Let me show. Let me see if I got it right. Convert. I may need to do the full binary. Let's see. See, it's not taken by this. Actually, it should be the right syntax. Okay.
Okay.
Yeah, but that's basically that's it. If I bring it here, let's try this one. I'm gonna paste that. So base 2 binary, do binary, binary bin, same thing. Print it out. giving us an error. So saying the name is not defined. So, but this is that's what we need. So if we were to do this, let's see, bin, okay, we want to define the name. Let's give it number 9. Okay, now we run it. 9. Okay. Let's try one more time. I don't know why it's not doing it.
I think you need to define the A or.
The A is defined here.
Oh, yeah, it's already defined.
Then yeah, and then you just bring it here, and then we. I don't know why it's getting that string. Anyway, sometimes it's gonna be a problem, but it's not really like there's an error. See, we bring it here. Let's see if it can say A, let's say 9. Here, we run that. Ooh, my computer is tired now. It's been running the whole time. It's not in printing now. But all in all, if you were to run this program, let me share this with you. This program should work for you. Okay. Like the decimal, the same. Did that answer your question?
Yes, yes.
Okay, cool.
But I also wanted to know the Python gonna do for us the binary, that is.
Yeah, and that's exactly what we were trying to do here. So we declare the value A, we put the value number 9 in A, and then we do the binary.
Okay.
Okay.
Yeah.
So for some reason, this one is showing a string, and I'm not really sure why, but this worked. We did it previously here before, and it worked very well. And that should be able to work for us. You see where it worked? Like
yeah.
we did binary here.
Okay.
The same thing we did here. If you were to do the same thing here,
okay.
I think I need to clear some of the memory, I think. And, let me just go back here. But run that. See, now it's running now. The same program now is running. So the B is binary and then number 9. So if you were to take 9 and then divide by 2, each time you divide by 2, you take the remainder, whether it's 0 or 1, you just put it there.
Okay.
Whatever you have, you divide by 2 until you reach the last digit, then it's going to be 1001.
I was trying to do this manually, and I didn't know that the interpreter will do it for us. So
oh, yeah. But I'm glad you tried it manually too. That way, it really sticks too. You really get to stick in your memory.
So can we be able to do manually to go back to the integer?
To go back to the integer?
Yeah.
Okay, let's see here. Okay, if you were to do the integer, you just do the integer here.
The laundry room.
Okay. Then you take this number.
Okay.
100. Okay. Then now we say print. Okay, this should be B. I don't know if it can work, but let's see without a B. Let's see here. Okay. Okay, see, it comes back.
Yes. Okay. Thank you. Yeah.
Thank you.
All right.
So remember that float, if you were to do that as a float,
Okay.
then that integer, whatever number you get in that before, you have to do, instead of that, you have to do float here. And then this one will be 4.4.
Okay.
Yeah.
Thank you so much.
Thank you.
All right.
Okay. Anybody else? Well, go ahead.
Okay, Mwalimu, just back to my question.
Go ahead.
How to, like, in future, I want to come up with a system that is able to manage all the fishermen around where I stay, because actually our main economic activity is fishing, and most of the fishermen are really suffering. They use the paper thing to check the number of fish, to record the number of visitors who come to the island. So it's somehow tedious. So I want to come up with a system that is able to capture all the fishing activities, the boats, the fishermen, the price. It's an holistic system.
Yes.
So how do I?
Say, how do you?
How do I make this idea real? Because right now it's in the brain.
Looks like it's about this. Okay, how much do you know in PHP?
PHP, I know about, not really 100%, but 50%.
Okay. So if you have an idea,
yeah,
go ahead and write it down. Okay.
Yeah.
So while excuse me, as you do this class, this will be coming along your way. And then you put this idea into use, just come up with a very rough program.
Yeah.
As you go along, you get really advanced.
Yeah.
Okay. Excuse me. And then sorry about that. I'm choking.
It's okay.
And most of the ideas you have are very good in in a mobile app.
Yeah.
Especially in that environment where you have to move around.
Yeah.
Yeah. So those are doable, and Python can do that for you. Python has a mobile part of it, which can do mobile programming with the database. Yeah.
Oh. Okay. Okay. Hello?
I'm still here. I can hear you.
Okay. So you say that still I can implement it using Python because it has some of the libraries.
Yeah. Python has a lot of libraries for data analytics, for big learning, big data and machine learning.
Okay.
So if you're dealing with a lot of data,
yeah,
most of the data you keep them in the database, but you want to do the analysis, and Python is good in that. So what you need to do, just sit down and write the ideas like writing a book or writing those ideas down exactly,
yes,
right?
yeah.
And then if you need help, I'll be more than glad to help you.
Okay, okay.
Yeah, excuse me.
Do you mind if we take a break, maybe call it a day?
I don't mind, man.
No, because of your condition. You take care of your condition.
No, I'm fine. I'm fine now, man. I've been having this cough for more than a month, but it's getting better. Yeah.
Okay, thank you. Sorry.
One thing I can promise is not COVID, because I went for COVID.
Yeah. You know, we lost two personalities.
Oh, you did?
Back at home.
Oh man, that's bad.
Yeah. One is a Mheshimiwa, the other one was the chairman of KFF.
Oh, I saw somebody from the coast and somebody from Western, right?
Yeah, from Western, yeah.
Oh, damn. May they rest in peace.
Yeah, sure.
Yeah, man. So I'm now the voice is coming back. So Python has a Python part of which can do we call it Kiva, K-I-V-A. That's Python which does mobile applications. So it can do mobile for like Android, or it can do mobile for iOS. So the good thing is it's across the board. So with your ideas, you just write them down. Let's say, look like you see your idea. You have a lot of so many things going at the same time, right? Like you want to take data of people who are coming in. You want to take data of the fish. You want to take data of. So you really have to separate the concerns. Separating the concerns, you need to make the system disparate. Like the system need to be decoupled. Okay, it's a big system. There's one part which is only dealing with the fish, another part dealing with the, let's say, with the people who are doing the fishing.
Yeah.
The question will be like, how would they be able to do it? They need a smartphone, right? So if your system can be on a smartphone and people are willing to buy the smartphone, if your system is good, then you know you're good. Yeah, so that would be a good area to get started with. It might not be like the system capturing everything, but it's going to be able to get a head start with that. With that analytics. I mean, people can download it and use it, but all they have to do is pay you for certain things in that system. Let's say if we need additional features, or if they can download it for free, but it's not going to be able to work until they download other features which they can pay for. So it could be a revenue stream for you. But sometimes if you have very good ideas, you don't want to share with a lot of people because they steal your idea.
Like I've really been thinking of that idea for a long time.
Yeah.
Accompanied with e-commerce for fishing. Yet it's just like where I come from is a very vast place, and there are very many beaches around the connections.
Yeah.
So you find that getting the fishing net, the floaters, getting the engine boards, those the necessary equipment that you can use to facilitate the whole fishing, they are not able to get, and most of the time they're exploited by the middlemen. suppose now you create a site whereby, like Jumia kind of, so you deal specifically with the fishing gears. So you can link both the fishermen to direct to the market if they want product common pool where they can easily access the suppliers and they're able to get things at a affordable price rather than interacting with cartels who overcharge them.
Okay. So it looks
Yeah.
like that's almost like a marketplace right there. For you. It's one big system, with a lot of small functioning independently.
Yeah. So it's a big system that requires at least you have to have a thorough understanding of Python so that at least when you begin to develop it up, then you actually know what you're doing.
That's correct.
Yeah.
I said Kiva, but it should be Kivi, the name, right?
Yeah.
So if you Google that, you'll find that's going to be Python for mobile development. Thank you, Sue, for correcting me.
You're welcome.
Yep. So anything else? Anybody? And it looks like you guys gonna build a system to land the next thing to the moon.
and Malim, also I've been thinking of Internet of Things, huh? Like you find that sometimes the fishermen down there, they are not able to predict when the fish catch is high, when the fish catch is low, or sometimes it becomes very stormy and messy. They are not able to predict that.
Okay.
So is there a way you can automate that, in that you can have some particular sensors, or you have to install some sensors under sea to collect information about fish temperature, and then.
Okay. So let me tell you how that can work. Sometimes there's certain things you cannot control. Like the natural stuff, let's say rainfall, temperature, the weather, and all this. But you can use some data from, let's say, the meteorological department to help you know the conditions, right? Because you don't need sensors under the sea, under the ocean, or under the sea, or under the lake to help you determine how the catch is going to be. But if you know the patterns, let's say during the rainy season, or during the when the moon is up, or during certain months, then you can be able to create a pattern to be able to tell when the catch is good. Okay.
Yeah.
So, for example, I'm not really sure, but you being from the lake, from that area of the lake, you probably know better, right?
Yeah,
so, you know, for example, let's say between January and March, there's gonna be rainy season around the lake, or maybe from February to April, and then that will be determined by the, let's say, the conditions, the monsoon winds and all that, which is affecting East Africa. And then based on that, you look at the data, if you already have the data existing. So you have the data from the meteorological department, and then you compare with the data from the fisheries department. And then you get what we call the data points, okay? And then you can draw stuff which will be able to, let's say, there's so many other factors which we call the independent variables, like so many x-axis, which will be able to help you to be able to get the y-axis you're looking for, which is the dependent, okay? So you don't have to go into the details of how can I get sensors, no. Just go to the fishery department. If they have reliable data, and the meteorological department also have reliable data, then you can get those. but you know where you guys come from, you're very close to Tanzania. So maybe you might need to compare both places. If you can get, some of this might even be available from the NGOs. Well, the NGOs might be keeping better data than in the government.
Actually, we sit between Uganda and Tanzania.
Okay. Okay, so you are pretty close to, you can get the data from Tanzania, data from Uganda, and data from Kenya. Okay, if you get 3 data sets, you can merge those 3 data sets, okay? And then you get the average. Say, it might not be different. Data from Uganda, for example, for the rainfall, and that one from Tanzania for the rainfall around the lake might not be very different. But you find that data from the lake in terms of the catch might be different. And again, you're going to drill down to to the type of fish you're going to be looking for. Let's say during the moon, when the moon is up, you might not get a lot of fish, or you might get a lot of fish. And what type of fish? Let's say, for example, it could be tilapia or it could be omena, you know. So those are different data sets you'll be looking at. And those are the ones you basically, you've heard of what we call API,
Yes.
interface. So if you feed that into your system the right way, the right data, then can be able to help you to predict. Some of the predictions might almost be like very close to what you're looking for. So it depends on the study and you asking around the experts. Yeah, there's so many things which will be affecting it, even the population, even the rainfall, the sunshine, the moon. There's so many things.
It's true. Like especially when the moon is up, there's no catch.
Okay. So, John.
Yes.
Looks like somebody's concerned. Your ideas are very good, but she fears somebody might steal your ideas. You need to talk to me privately.
So.
Okay. She's very concerned. I think that's right. I think that's really true. Not that somebody's going to do it, but again, your ideas should be proprietary to you.
Okay.
Yeah. Okay.
Thanks.
Any question? No problem. Feel free to inbox me and whatever, man. If I don't answer, maybe just not available, but anybody just feel free to inbox me so we can be on the same page. I would like to see how you guys progress. Yeah.
Okay.
Okay.
Thanks.
Thank you. Anybody else? Anybody else? Any question? Okay. If we don't have anybody else with any question, then I'm gonna go ahead and again, thank you guys very much for taking your time. I know you could have been doing something else, but you decided to come and sit with us for almost over 2 hours.
Yeah.
I hope we covered everything we needed to cover, but we'll be having another Zoom session. Now you realize why I say it's only 3, because I mean, one Zoom session is only going for like minimum 2-3 hours. So sure. I open it up for any question, even in the WhatsApp. I'll share more notes. I'll also make available tonight or today for the Kenyan people, available for another quiz. I'll make it 30 questions covering those sections we touched. And then I'll also upload another book. The book is very good, but don't be fooled by the title of the book. You know, if you see the book, don't see like somebody think you're dumb. No, but it's a very good book. Personally, I always go back and forth and read it. So again, thank you guys very much, and I wish you well until we meet again. You have a good one.
Yeah.
Thank you.
Have a good day, Migot, and
Maybe for the class, they can always encourage the others to come.
Oh, yeah.
Yeah.
Please, I know everybody's different, but if you know somebody who is willing to come, just drag them along and we're here.
Yeah.
Okay.
Yeah.
Thank you. All right. Good night.
Good night. Thank you.
Thank you.
Thank you.
Thank you.
Good night.
Good night.